server in Jakarta server pages. Now we are focusing on server. Server, network computer program or device that processes request from a client. In the Java world, a servlet container, also known as web server, is like a light beer version of an application server. A servlet container handles request and response interactions and allows those interactions to interface with a subset of Java enterprise capabilities for web applications. A Java application server includes the servlet container as part of the full Java enterprise stack, including EJB, JPA, JMS, and more. Here you can see the container types in Java E server and containers here. The deployment process install Java E application application component in Java E containers as illustrated in this figure. The Java E server, the runtime portion of a Java E product. A Java E server provides EJB and web containers. Enterprise Beans EJB container manages the execution of enterprise beans for Java E applications. Enterprise beans and their container run on the Java E server. Web container, the manages the execution of JSP page and servlet components for Java E applications. Web components and their container run on the Java E server. Application client container manages the execution of application client components. Application clients and their container run on the client. Applet container manages the execution of applets, consists of web browser and Java plugin running on the client together. Here you can see application client is inside application client container. And application client container and web browser are inside the client machine. Client machine interacts with here EJB container, and EJB container interacts with the web container, and web browser interacts with the web container. Here the servlets and JSP pages are inside the web container, and enterprise beans and are inside EJB container. Web container and EJB container inside Java E server. Here the EJB container interacts with the database. Here you can see the architecture of Java based web server. One web server is started, one daemon process, once the web server is started, one daemon process will be started to listen the clients continuously and to trap and take the client generated HTTP requests. The process that runs continuously is called daemon process. Every Java application contains two default threads. One main thread and two garbage collector threads, daemon threads. JSP container is the enhancement of servlet container. And both containers are JRE and JVM supplied web server. Sorry, both containers use JRE or JVM supplied by web server. Middleware services are configurable additional services on the application to make applications executing perfectly in all the situations. Security middleware service protect the application from unauthorized and unauthenticated users. Transaction management service executes the logics by applying do everything or do nothing principle. JDBC connection pool supplies a set of ready available JDBC connection objects. Logging service keeps the tracks of the application execution process through confirmation statement or messages or log messages. Middleware services are not minimum logics of application deployment. They are additional or optional services to apply on applications. Web application can be can be there with or without middleware services. Web server automatically activates servlet container and JSP container to execute servlet JSP programs when they are required by clients. The client side of web resource programs of web application goes to the browser window for execution, whereas the server side programs will be executed by using the containers web server. Web application executing environment browser software is called as the client software, and web server software is called as the server software. Here you can see the machine, and inside the machine you can see web server Java based. Inside the web server you can see middleware services, JDBC connection pool, security, transaction management, logging and others, and JSP container. Inside JSP container, so you can see the servlet container. Inside servlet container, there are deployed web applications, servlet program, JSP program, image file, and HTML program can be in deployed web application. As an example, we can consider Apache Tomcat. Apache Tomcat, called Tomcat for short, is a free and open source implementation of the Jakarta servlet, Jakarta expression language, and WebSocket technologies. Tomcat provides a pure Java HTTP web server environment in which Java code can run. Oracle WebLogic Server. Oracle WebLogic Server is a Java EE application server currently developed by Oracle Corporation. Oracle acquired WebLogic Server when it purchased BEA Systems in 2008. As an example 3, we can consider this. This is in a WebLogic 12.2.1.4 JSP and Java EE. This is configuring Java server pages JSPs in JSPs where WebLogic 12.2.1.4. In order to deploy Java server pages, JSP files, you must place them in the root or in a subdirectory below the root of a web application. You define JSP configuration parameters in sub-elements of the JSP descriptor element in the WebLogic specific deployment descriptor weblogic.xml. These parameters define the following functionality: options for the JSP compiler, debugging, how often WebLogic server checks for updated JSPs that need to be recompiled, character encoding. Now we are considering protocol seen by the web server in JSP page model in JSP container. The servlet class defines the contract between JSP container and the JSP page implementation class. JSP container locates the appropriate instance of the JSP page implementation class and delivers the request to it using servlet protocol. A JSP container may need to create such a class dynamically from the page source before delivering request and response object to it. The servlet class defines the contract between JSP container and JSP page implementation class. When HTTP protocol is used, the contract is described by the HTTP servlet class. Most JSP pages use the HTTP protocol, but other protocols are allowed by this specification. The JSP container automatically make a number of server-side objects available to the JSP page implementation object. Here we are considering servlet as an example. Now we are considering the protocol seen by the JSP page author in protocol seen by the web server in JSP page model in JSP container. The main portion of this contract is the _JSP service method that is generated automatically by the container from the JSP page. The interface the method void _JSP service Jakarta.servlet.http.http servlet request Jakarta.servlet.http servlet response. In the interface HTTP JSP page in the package Jakarta.servlet.jsp in the module Jakarta.servlet.jsp. The _JSP service method correspond to the body of the JSP page. This method is defined automatically by JSP container and should never be defined by the JSP page author. The JSP specification defines a contract between JSP container and the JSP page author. This contract defines the assumptions an author can make for the action described in the JSP page. The main portion of the contract is the _JSP service method that is generated automatically by JSP container from the JSP page. The details, JSP page. The contract will also describe the new how a JSP author can indicate what actions will be taken when the init and destroy methods of the page implementation occur. In JSP 3.1, this is done by defining the methods with the names JSP init and JSP destroy in a declaration scripting element in the JSP page. JSP init method, if present, will be called to prepare the page before first request is delivered. Similarly, a JSP container can reclaim the resources used by JSP page when the request is not being served by the JSP page by invoking JSP destroy method if present. The JSP page author may be redefined servlet methods through a declaration scripting element. JSP specification reserves names for methods and variables starting with JSP, JSP X and JSP X in any combination of upper and lowercase. Now we are considering omitting the extents attributes in JSP page implementation class. This is a generic HTTP superclass. The interface HTTP JSP page in package Jakarta.servlet.jsp in module Jakarta.servlet.jsp. The HTTP page interface describes the interface action that the JSP page implementation class must satisfy when using the HTTP protocol. If the extents attribute of the page directive in a JSP page is not used, the JSP container can generate any class that satisfies the contract a different way in when it transforms the JSP page. This code examples illustrate a generic HTTP superclass named HTTP example HTTP super, and is the class generated from the JSP page by using separate underscore JSP 1344 and example HTTP super classes. The JSP translator does not need to discover whether JSP page includes declaration with JSP init or destroy. This significantly simplified the implementation. This one is not final, so it can be overridden by a more precise method. Maybe better. The entry point into service. The casting exception will be raised if an internal error. Abstract method to be provided by the JSP processor in a subclass. The subclass must be defined in a subclass. An example of a class generated for JSP and the name of the class is unpredictable. We are assuming that this is an HTTP page like Ola. Next code inserted directly via the declaration, and any of the following pieces may or may not be present if they are not defined. Here the superclass methods will be used. The next method is generated automatically by the JSP processor body of the JSP page. The initialization of implicit variables. Next is the code from scriptlet expression and static text. Now we are considering buffering. The JSP writer class is used in the underscore JSP service method as in the following example. The class JSP writer in package jakarta.servlet.jsp in module jakarta.servlet.jsp. The actions and templates data in the JSP page is written using the JSP write object that is referenced by the implicit variable out, which is initially automatically using the methods in a page context object. JSP container buffers data if the JSP directive specified it using the buffer attribute as it is sent from the server to the client. Headers are not sent to the client until the first flush method is invoked. Therefore, it is impossible to call methods that modify the response header, such as set content type and send direct or error methods up until flush method is executed and the headers are sent. After that point, these methods become invalid as per the servlet specification. The jakarta.servlet.jsp.jsp writer class buffers and send the output. The JSP writer class is used in the JSP service method as in this example. Complete listing of the jakarta.servlet.jsp.jsp writer can be found in the jakarta.servlet.jsp Java doc. With buffering turned on, a direct method can still be used in a scriptlet in .jsp file by invoking response.redirect some URL directly. Initialization of implicit variables. The body goes here using out. Now we are considering pre-compilation protocol in pre-compilation. For example, here a request to a JSP page, JSP page that has request parameter with the name JSP underscore precompile is a precompilation request. The JSP underscore precompile parameter may have no value or may have values true or false. In all cases, the request should not be delivered to the JSP page. The intention of the precompilation request is that of a suggestion to the JSP container to precompile the JSP page into a JSP page implementation class. The suggestion is conveyed by giving the parameter the value true or no value, but note that the request can be ignored. For example, this. The 1, 2, 4 and 4 are legal. The request will not be delivered to the page 3. To the page 3. Request will not be delivered to the page. The 3 and 5 are legal. Request will not be delivered to the page. This is illegal and will generate HTTP error. The 500 serve error, this one here. Now we are considering line number mapping guidelines in debugging requirements. Where possible, the JSP container should generate line numbers mappings as follows. The following is a set of non-normative guidelines for generating high-quality line number mappings. The guidelines are presented to help produce a consistent debugging experience for page authors across containers. Where possible, the JSP container should generate line number mapping as follows. 1. A breakpoint on the JSP line causes execution to stop before any Java code that amount to a translation of the JSP line is executed for one possible exception, C5. Note that given line info composition algorithm, Jakarta debugging support for other language specific it is acceptable for mappings to include one or more Java lines which are never translated into executable bytecode as long as at least one of them does. 2. It is permitted for 2 or more lines of JSP to include the same Java lines in their mappings. If the line of JSP has no manifestation in the Java source other than white space perceiving source, it should not be mapped. The following standard syntax of JSP entities should not be mapped to generate code. Those entities have no manifestation in the generated Java code commit, so are not to manifest in such a way that it allows the debug process to stop. For example, page directive import, JSP comments and directives. The following XML syntax JSP entities should not be mapped to generated code. These entities frequently have no manifestation in the generated Java code. JSP:root, JSP:output. For the decoration and scriptlets standard or XML JSP, lines in these construct should preserve to one-to-one mapping with the corresponding generator's code lines. Empty lines and comments lines are not mapped. For scriptlets, scripted expressions, EL expressions, standard actions, and custom actions in template text, a line containing one or more of these entities should be mapped to a Java source lines which include corresponding Java code. If the line start with the template text, the Java code which handles it may be executed from the mapping of if it would cause debugger to stop before apparent execution JSP line proceeding the line in question. For a scriptlet that contains more than one line, there should be a one-to-one mapping from JSP to Java lines. And the mapping should start at the first Java code that is not white space or comment. Therefore, the line that contained only one open scriptlet delimiter is not mapped. 6 scriptlet expressions and EL expressions in attribute values. The source line mapping should include any Java source lines that deal with the evaluation of the RT value as well as source that deals with the JSP action. Standard or custom actions, empty tags and start tags special case. The JSP param section typically has no manifestation and should not be mapped. Empty tags and start tags, the Java line mapping should include as much of the corresponding Java code as possible, including the separate lines that deal with the RT EXPR evaluation as described in 6. If it is not possible to include all the Java code in the mappings, the mapped line should include the first sequential line which deals with the with other line either tag or attribute evaluation in order to meet one. Closing tags frequently do not have a manifestation in the Java source, but sometimes do. In the case a JSP line contains only a closing tag, the line may be mapped to white space prevailing the Java source if it has no semantic translation. This will avoid a confusing user experience where it is sometimes possible to set breakpoint on a line consisting of a closing tag and sometimes not. Now we are considering web containers and web components in what is JSP page in core syntax and semantics. JSP container is a system level entity that provides lifecycle management and runtime support for JSP pages and servlet components. Requests sent to JSP page are delivered by JSP container to the appropriate JSP page implementation object. The term web container is synonymous to the JSP container. Web component is either a servlet or JSP file page. The servlet element in web.xml deployment descriptor is used to describe both types of the web container components. JSP page components are defined implicitly in the deployment descriptor through the use of implicit.jsp extension mapping and explicitly through a use of JSP-group element. Now we are focusing on servlet filter. This is controller. Jakarta servlet, formerly Java servlet, is a Java software component that extends the capabilities of a server. Although servlets can respond to many types of requests, they most commonly implement web containers for hosting web applications on Java servers and thus qualify as a server-side servlet web API. Such web servlets are the Java counterpart to other dynamic web content technologies such as PHP and ASP.NET. A filter is an object that performs filtering tasks on either the request to a resource, a servlet or static content, or on the response from a resource or both. Here you can see life of a JSP file. Here the JSP container, here the translation occurs at this point if JSP has been changed or is new. If not, translation is skipped. So this is translation passed, and if not, this is Jakarta servlet, formerly a Java servlet. A Jakarta servlet possesses or stores a Java class in Jakarta EE that conform to Jakarta Servlet API. A standard for implementing Java class that responds to requests. Servlet could in principle communicate over any client server protocol, but they are most often used with the HTTP. The servlet is often used as shorthand for HTTP servlet. Thus, a software developer may use a servlet to add the dynamic content to a web server. Using Java platform. The generated content is commonly HTML. But may be other data such as XML or more commonly JSON. Servlets can maintain state in a session. Servlet can maintain state in session variables across many server transactions by using HTTP cookies or URL mappings. Jakarta Servlet API has to some extent been superseded by two standard Java technologies for web services: the Jakarta RESTful Web Services JAX-RS 2.0, useful for AJAX, JSON, and REST services, and the Jakarta XML Web Services JAX-WS, useful for SOAP web services. To deploy and run a servlet, a web container must be used. A web container, also known as a servlet container, is essentially the component of a web server that interacts with servlets. The web container is responsible for managing the lifecycle of servlets, mapping a URL to a particular servlet, and ensuring that the URL request has the correct access rights. The servlet API contained in the Java package hierarchy javax.servlet defines the expected interactions of the web container and a servlet. A servlet is an object that receives the request and generate generates the response based on the request. The basic servlet package defines Java objects to represent servlet request and responses, as well as objects to reflect the servlet's configuration parameters in the execution environment. The package javax.servlet.http defines HTTP specific subclasses of generic servlet elements, including session management objects and that track multiple requests and responses between web server and the client. Servlet may be packaged in a WAR file as a web application. Servlets can be generated automatically from Jakarta server pages. JSP by Jakarta server pages compiler. The difference between servlets and JSP is that servlets typically embed HTML inside Java code, while JSPs embed Java code in HTML. While the direct usage of servlets to generate HTML has become rare, the higher level of MVC web framework in Jakarta EE, JSF, still explicitly uses the servlet technology for the low-level request response handling via the Faces servlet. A somewhat older usage is to use servlets in conjunction with JSP in a pattern called Model 2, which is a flavor of Model View Controller. The current version of servlet is 5.0 at this moment. Here you can see JSP containers. Here you can see the JS request is passed from client to JSP page.jsp, and there are the if the translation occurs at this point, if JSP has been changed or is new, then JSP page is connected to JSP translator here, for example Tomcat, and JSP translate is connected to JSP source code Java, and JSP translate is connected to servlet source code Java. Servlet source code is connected to Java compiler embedded server. Java compiler is connected to server class, and JSP translator, and servlet source code, and Java compiler and server class is inside translation page, and server class is connected to JRE. JRE is connected to text buffer in memory. JRE and text buffer is connected to execution page, and text buffer is connected to client. Response is passed from text buffer to client. And here if not translation is skipped, here that if JSP has not been changed or not new, then translation is skipped, and then JSP page.jsp is connected to text execution page here, and it's connected to text buffer here in memory, and text buffer is connected to client here. Response is part from text buffer in memory to client. Now here you can see the illustration is detailed step-by-step description of each number in the image in MEC with servlet and JSP. Servlet were very popular even JSP's first arrived, and because of easy to use and fast deployment model, they were used to do everything. MEC using JSP is possible, but scriptlets make your pages very hard to read, and when you start mixing JavaScript, CSS, HTML and Java all in one files, it's easy to get the 1000 lines, meaning that the output will normally be a long HTML file that will take a lot of time to load, render and execute JavaScript code, not to mention the readability problem. To avoid the separate Java code from the separate Java code from HTML, normally servlet is used. The servlet do all the heavy lifting, load model data, process, modify it, and then save it back, and then add it to the request as described, request as attributes, and dispatch it to the JSP file that will use the expression language. And taglibs to generate HTML code that will be rendered on the client side. Some people even argue that that makes it easy enough for designers to generate HTML in those fancy design tools like Dreamweaver or Illustrator, but some people don't like the automatically generated HTML because the tools still aren't good enough, and designers and programmers, most of them don't like to be responsible for HTML, and they aren't paid to do that. Some people think that is a part of their job. Back to the MEC stuff. The following is the illustration that shows how request and response flow is handled. Handles then in a sample project. After the illustration is we are going to describe a detailed description of each number of in the image. One, the Tomcat receives the request and passes it to the base servlet. That is an abstract servlet class that all servlets should be extended to get the basic request response functionality. Step 2, the base servlet calls the execute method of the subclass. Step 3, the execute method is where the real action happens, and all exceptions should not be handled. And there is here is where the servlet access the data access layer. For data access layer handle all conversation with the database and passes only object back to the servlet. 5, after loading or updating the data subclass of base servlet, only need to return a string that says how the response should be handled. The dispatch method will handle the forwarding to JSP or a redirect instruction back to the browser. If an exception is thrown by the execute method, it will be handled and redirected to the error.jsp page. Here JSP's base servlet and servlet subclass, DAO and databases are in this picture inside the Tomcat web server. The request is connected to do get or do post, and do get and do post interacts with the base servlet, and then base do post in here then base servlet interacts with execute in here the servlet subclass, and execute interact with the data DAO, and DAO interacts with the database, and here the dispatch is connected to JSPs, or here the then dispatch, and the dispatch is connected to response via error or redirect. Here you can see a servlet filter in a Java web application. A servlet filter is an object that can intercept HTTP request targeted at your web application. Servlet filter can intercept requests for servlet, JSPs, HTML files, or other static contents, as illustrated in this diagram here. So here servlet filter and servlet, JSP, and static file are inside web app. HTTP request is connected to servlet filter. Servlet filter is connected to servlet, JSP, and static file. Now we are considering working of a JSP filter. JSP filters are the Java classes that primarily are used for intercepting the request from any client or to manipulate the server response. Additional techniques like logging and auditing are used by the filters to provide functionality of data security by encrypting the data, as well as providing the user authentication. To create and implement the filter interface, the older java.servlet class can be employed, or Jakarta.servlet class can be employed. Apart from JSP, servlet, and other markup languages like HTML make use of filters. Moreover, we can also see the use of filters in images and videos as well. It is evident that in some conditions where it is required to degrade the performance of say videos, filters are being used to add some extra complexity, maybe because it is very fast and very much accessible by different user environment. The web.xml file, which is used to define filters, are being mapped to servlet and or JSP pages in order to use the filter functionalities. JSP containers are invoked when JSP codes are run, and at the same time an instance of filters that are deployed in the deployment descriptor file is created. Here the request is connected to filter, and filter 1 and filter request is it is connected to filter 1 via request, and filter 1 is connected to filter 2, filter 2 is connected to filter 3, and filter 3 is connected to JSP, and JSP is connected to filter 3, and filter 3 is connected to filter 2, and filter 2 is connected to filter 1, and filter 1 provides response. Here you can see the filters are called by the application server, both prior to and subsequent to the resource processing of a request. This figure illustrates the simplified view of a middle tier server, emphasizing the request and response flow, and showing where the filters fit in the picture. You can see that the filters are positioned in the processing pipeline between the application server and the client. Filters provide application level access in the request handling pipeline of a container. Before the advent of filter, there was no way for a web applications to participate in the processing being performed along with the request handling path. A web application could only supply and define the resource that were being served. If the application required to access the processing pipeline, you have to resort to non-portable server level extension interceptors valves and like which you will and other stuff. Due to their strategic position in the request processing pipeline, filters can easily handle the pre and post processing of request for resources such as HTML pages, JSP pages, and servlet. This specialized construction of filters will actually allow them to participate in the processing of a request or response throughout the processing path. You also have to the option to chaining several filters together dynamically to process each incoming request. This allows the filter deployer to combine the action of 2 or more filters at deployment time. At runtime, the container uses filter mappings to determine the filters or filters each request and response will pass through. Here you can see the incoming request is connected. Incoming request is passed to the filter 1, and filter 1 is connected to filter 2, and filter 2 is connected to process resource. Process resource and filter 1 and filter 2 are inside the application server. You can here you can see the processing pipeline, and process resource interacts with static HTML, servlet, and JSP page. And process resource is connected to filter 2, and filter 2 is connected to filter 1, and filter 1 is passing ongoing response. Here you can see filtering pipeline. Filters can act as filters can act on a request before it reaches to the resource, and on the response after the resource has been accessed. Filters enable a developer to tap into the pipeline request and response processing. A filter can do its work just before a resource is fetched or executed in the case of dynamic output, and immediately after the resource is fetched and executed. It's even possible to inject custom behavior while the request is being processed by the resource. More specifically, when you apply this notion to the HTTP based request and response that serviced by a middle tier servers, filters can be used to do following: inspect the request header and data before it reaches to the resource, inspect the response header and data after it has been sent by the resource, provide modified version of the request to the resource being processed by the container, access and modify the response from the resource being resource before returning it, and stop request from reaching a resource altogether. You will examine you should note that the code implement in filters can have the same power, if not more, as the code implement in resources. In other words, servlets and JSP pages when it comes to the request processing. In some way, you can view the servlet engine and JSP engine simply as endpoint filters in this processing pipeline. Here you can see it's connected to the filter, and this filter is connected to this one, and here the filter has access to request before resource processing, and this filter is connected to this filter, and this filter is connected to resource processor, and resource processor connected to this filter. And here the filter can supply wrapped version of request and response for custom behaviors, and this is connected to, and here the filter has some filter access to response after resource processing, and this filter is connected to this one, and then it's provide response. Here this is the filter pipeline. Now we are considering life cycle of a filter. Here the life cycle of a filter is similar to the life cycle of a servlet. The filter is created, then initialized, it processes requests, and it is destroyed when no longer needed. Just like servlet and JSP pages, container manages the life cycle of a filter. Now here we are considering a filter. This figure illustrates the life cycle of a filter by using block diagram to represent states that the filter can be in. As you can see, the filter life cycle is almost identical to that of the servlet life cycle. The 4 stages of the filter life cycle: instantiation, initialization, filter execution, and destruction. Of the 4 stages, there are only 2 explicit states: initialization and initialization and filter execution. In the other 2 stages, the filter's instance does not exist. It is either being created or being destroyed. For each filter definition in the web application, as specified in the web.xml, the container will create an initialized the filter instance. Every filter must implement the Jakarta.servlet.filter interface. This interface defines 3 methods: init, do filter, and destroy. These 3 methods and constructor corresponds to 4 stages of the filter life cycle. The construct is called during instantiation phase. The init method is called for initialization. Do filter method, which contains all the filter processing logic, handles the filter execution phase. Finally, destroy method is used in the destruction phase. That single filter instance, which is the initial parameters, will service all requests that correspond to its filter mapping specified within the deployment descriptor. The only exception to this occurs when the engine consists of multiple virtual machines, VMs, servicing requests. In this case, the container mechanism will create one instance for each VM, thereby allowing all participant VMs to service filtered requests equally. The container will call destroy when the web application is shut down. The initialization must occur before the first request is mapped through the filter instance. During the initialization, the container passes filter config object via the init method of the Jakarta.servlet.filter interface, Java.servlet.filter interface. The filter config can be used by the filter to obtain initialization parameters of the filter, the textual name of the filter, or filter context that application running under. Here the uninstantiated is connected to instantiated. It is connected to initialize via init, and initialize is connected to service request. Servicing request are connected to itself via do filter, and servicing request is connected to garbage collection and finalization via destroy. Now we are considering insertion of filters into the request flow. Here the incoming request is processed by 0 or more filters, and the response from the web server can be processed by the same set of filters. The filters and request dispatcher, to better understand how the request dispatcher interact with filters, we will process the series of figures depicting this request flow in a servlet container. Here we can consider Action Servlet 3.2 compliant containers. These containers support filters but don't support interact with the request dispatcher. This illustrates the filtering that will be performed. This figure is the conventional request flow. The incoming request is optionally passes through a mapped filter change before being sent to the final processing resource, typically a servlet or a JSP page. This is typical filtered request flow for all the Servlet 2.3 compliant containers. Here the incoming request is passed to F1, and F1 is connected to F2, and F2 is connected to S3, and F3 is connected to resource, web resource, and web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1. Then F1 is passing a providing outgoing response. Here you can see when a resource in a server 2.3 container includes other resources, these resources do not get processed by filters. This figure reveals what happens when you use same filter mapping in two resources that are included by the main web resource via request dispatcher.include in a servlet or an include directive in JSP when using servlet 3.2.3 compliant containers. Here the incoming request is connected to is passed to F1, and F1 is connected to F2, and F2 is connected to F3, and F3 is connected to web resource, and web resource is connected to F3, and F3 is connected to F2, and F3 is connected to F1, and F1 is providing passing outgoing response, and here web resource is connected to interacts with included web resource A, and web resource is interacts with included web resource B. In other words, under servlet 2.3, here you can see in the servlet 2.3 containers, filters are not applied to these request for or response between original resource and the forward resource. Filters only applied between client and the request resource. In other words, under servlet 2.3 compliant container control, when the primary web resource uses request dispatcher to include the other processing resources, included the processing resource cannot be filtered. The same thing happens when the web resource uses request dispatcher to forward the request to other processing resource via the request dispatcher.forward method in the servlet, in a servlet, or JSP :forward in a tag in JSP. This figure illustrates this situation. Here you can see incoming connection is incoming request is passed to F1, and F1 is connected to F2, F2 is connected to F3, and F3 is connected to web resource. Here web resource is connected to forwarded web resource via forward, and forward web resource connected to a web resource. And here the F3 is connected to a web resource, and web resource is connected to F3, and F3 is connected to F2, and F2 is connected to F1, and the outgoing F1 is providing outgoing response. Here you can see when a resource in a servlet 2.4 or 2.5 container includes another resource, 0 or more filters can be applied as part of the inclusion action. A container such as Tomcat 5.5 allows filtering to occur in both the include and forward action of the request dispatcher. The dispatcher element of the filtering mapping allows you to specify that filtering is to be performed regular request dispatch as well as when the request dispatch is called to include additional web resources. This figure illustrates the action of the filter mapping on the included web resources. Now filters can be applied in between the first processing. Filtering can be applied between the first processing resource and any included resources. For example, if the first JSP page include the output from the multiple JSP pages or servlet, the filters could be applied for each included resources. Here the incoming request is connected to F1 and F1 is connected to F2 and F2 is connected to F3 and F3 is connected to web resource. And here the is include F1 web resource interact with F1 and F1 via include, and F1 is connected to F2 and F2 connected to F3 and F3 is connected to included web resource A, and included web resource is connected to F3 and F3 is connected to F1, F2 and F2 connected to F1, and F1 is interacts with web resource. Here web resource is connected to F3 and F3 is connected to F2 and F2 is connected to F1 and F1 is providing outgoing response. Here the 0 or more filters can be applied to the request and response when a resource forward the request to another resource. In this case, the filter chain will operate in both standard request processing and the forward resource processing as shown in this figure. This time the first web resource uses the request dispatcher forwarding capability. The resource that request is forwarded to is responsible for generating the actual output for the client. Here the filters are applied before the primary web resources and before the resource being forwarded to. The filter interaction with the dispatcher are controlled by the dispatcher sub-element of the filter dash mapping. Here the incoming request is connected to F1 and F1 is connected to F2 and F2 is connected to F3 and F3 is connected to web resource. Here the web resource interacts with F1 via forward. Here the web resource is connected to F1 via forward, and F1 is connected to F2 and F3 is connected to F3. F3 is connected to forward web request A, and forward web request A is connected to F3 and F3 is connected to F2 and F2 is connected to F1. And F1 interacts with web resource is connected to F3 and F3 is connected to F2 and F2 is connected to F1, and outgoing F1 is providing outgoing response. Now we are considering filter chaining, and all filters are chainable. For example, the design of the filter API provides an inherent chaining capability. The container works with each filter to filter and process the request as specified in the deployment descriptor. The compatibility with filter chaining is an integral requirement of every filter. Filter chaining is provided by the series of interaction between the container and the filter. This figure is a UML diagram of the interactions. Here is an explanation of what happens. 1. The container passes the filter mappings defined in the web.xml file of the application. 2. The request arrived accessing the resource in the application. 3. Container determines the filter chain that will be applied to the request. The container invokes doFilter method of the first filter of the chain passing the request and response holder in the filter chain object reference. The container loads the filter chain information into the filter chain object that is passed in. Filter chain performing its doFilter logic. 5. 6. Filter chain completes its filter logic and calls the doFilter method in the filter chain object reference, passing it to the request response. All filters are required to do this because all filters are intrinsically chainable. 7. The logic in the doFilter method of the filter chain object calls doFilter method of the next filter chain to be called. Steps from step 4 are repeated until the last filter in the filter chain has completed its work. The filter chain.doFilter call on the last filter call the last filter in. The note that the mechanism of chaining is inherently different from the most of other conventional filtering and server extension mechanisms such as Apache modules and Microsoft Internet Information Server and Internet Server API. Here you can see chain, container, filter, and next filter in chain. The step 1 container passes the filter mapping. Step 2 the request arrives, and step 3 container determined which filter chain to apply to the request, and 4 calls doFilter process passing in the filter chain object. 5 perform doFilter logic of filter. 6 call the filter chain doFilter, and filter chain.doFilter calls the doFilter of the next filter in the chain. Now we are considering terminology also here. A request from a client constitutes the downstream inbound trip of a request response cycle. The response from a web application constitutes the upstream outbound trip. Before you read any this figure shows the request from a client as request flows through the set of filters and handled by the web resource. Notice this figure shows filter 3 being applied twice to request response cycle, or although this is not the common practice, it is technically possible. For example, you could have a adapter filter that modifies the request. Using initialization parameters, you could control how the filters modifies the request. Thus, one instance of the filter could modify one aspect of the request, and the second instance of the same filter could modify the different aspect of the request. The request originates from the client and goes through the chain of filters before reaching the final resource processor. In this figure, the first request travels from the client through the first filter, through the second filter, then so on. We will call this the downstream or inbound trip. The downstream trip always forward the final goal. The resource processor. After the resource processor is finished with the request, the response then will travel the upstream or outbound back through the filters and onward to the client. Upstream trips are always anyway away from resource processor and forward to the client. New to Servlet 2.4 is the ability of filters and filters to participate in forward and include redirection request of the request dispatcher. This is very important advanced architecturally. Here you can see client is connected to filter 1 and filter 2, and then for the filter 1 is connected to filter 2, and filter is connected to filter 3, and filter 3 is connected to resource processor, and resource processor connected to filter 1 and filter 3, and filter is again connected to filter 3, and filter 3 is connected to filter 2, and filter 2 is connected to filter 1, and filter 1 is connected to client. Here you can see the from client, the downstream, and here an inbound or inbound, and here the to client, the upstream or outbound. Now we are considering a filter in the request processing pipeline. In the pipeline model, different processes can act upon the request as it travels through the system. There are many names given to the pipeline data processing model. It is often identified as enabling element of model view control MVC web application design, and sometimes it's referenced to as push model of application design in contrast with the more conventional push model. The idea is simple, but you have to think beyond the conventional web application wisdom to get bigger picture. Consider the illustration of the model shown here. The request enters to the system and is shuttled along a pipeline. As it traverses the pipeline, the sequence of processors has to access the content of the request. Each processor perform some task on the request, and then it either adjusts to some new attributes or modify the existing attribute as the request of the work. Then the request remain intact until it hits the final stage of the pipeline, which is especially processes called renderers. Examine all work being done to the request and produce the final response. Renders are always called view component in MVC paradigm because they alone are responsible for final presentation of the user. You can see why this is often called push model. The data attributes are fetched by the processors, pushed along the pipeline with the request, and the renders only at the final stage. The another common analogy for pipeline model is the conveyor belt or assembly line. Each processor mirrors the workers or robots along the belt or line. Some of the highly desirable properties of a pipeline model are as follows. The request stays intact as it traverses the pipeline, with the work being carried out only on the attached attributes, sometimes called decorators. Data management, business logic and presentation logic can be cleanly separated into different processors and renderers. The processors can be designed to completely composable, that is changed in any order, or highly specialized to work only with the specific attribute created or modified by the other processors. Multiple renders can compose finally output such as data to XML or HTML via XLLT. The state of the request travel with the request through the pipeline. The processors and renderers don't keep track of the requested independent state at all. This makes it possible to duplicate or shuttle the request and its state before multiple POSIX servers if necessary. In general, designing request handling logic by using pipeline model provides the following: processors and renderers that are readily reusable as components, strong and clear separation between data management and business logic and presentation logic in an application. Applications that are more maintainable, applications that are more adaptable to changing business requirements, robust applications that will be scalable with container technology and hardware advances, web application whose performance is highly optimizable. The last point may not be immediately obvious, but any processes in the pipeline that don't depend on other outcomes can in principle be executed concurrently, perhaps on two physical processes, for instance, and any grouping of the process that has an outcome independent of others can execute concurrently. In the past, the limitation of container implementation have prevented the use of clean pipeline design model. Servlet 2.5 has features that bring a dream of creating pipeline applications closer to the reality. Here you can see the request flow, and this is the pipeline here. Here the request flow interacts with processes, and here the request interacts with processor renderer and is provide response out. As an example, we can consider this code segment. Here the next let's update the JSP page to work with Java servlet. The idea is adding a web form, and on submit, the form will be processed by a servlet. At this code between the body tags of the page, this HTML code adds a form with the text field and a submit button to the page. The action attributes of the form specify the URL handles this form's submission. In this case, we specify the path which is relative to the application, and it points to the Java servlet which we will create. As an example too, we can consider Jakarta.servlet, the module Jakarta.servlet here. As an example 3, we can consider package Jakarta.servlet. The Jakarta.servlet package contains a number of classes and interfaces that describe and define the contracts between a servlet class and the runtime environment provided for an instance of such a class by a confirming servlet container. For versions prior to 4.0.2, these classes and interfaces are described by the Java Servlet API specification. For version 4.0.2 and later, they are described by the Jakarta Servlet specification. This package is in module Jakarta.servlet. As an example 4, we can consider this servlet. This example servlet prints how many times its service method was called. Here the class HTTP servlet provides an abstract class to be subclass to create an HTTP servlet suitable for website. A subclass of HTTP servlet must override at least one method, usually one of these: doGet if the servlet supports HTTP GET request, doPost for HTTP POST request, doPut for HTTP PUT request, onDelete for HTTP delete request, init and destroy to manage resources that are held for the life of the servlet. Get servlet info, which the servlet uses to provide information about itself. There's almost no reason to override service method. Service handles HTTP request by dispatching them to the handler methods for each HTTP request by request type. The do access methods, the do xxx methods listed previous here. Here the method void init servlet config called by the servlet container to indicate to a servlet that the servlet is being placed into service. The protected void service, HTTP servlet request and HTTP servlet response receives standard HTTP request from the public service method and dispatches them to the do xxx method defined in this class. Here you can see the destroy public void destroyed method called by the servlet container to indicate to a servlet that the servlet is being taken out of the service. As an example 5, we can consider interface servlet. Interface servlet defines method that all servlet must implement. A servlet is a small Java program that runs within a web server. Servlet receive and responds to requests from web clients, usually across HTTP, the hypertext transfer protocol. This interface is in package Jakarta.servlet. And here is the code example of a Java servlet which supposed to handle a logging request. It redirects the user to the home page if logging successful. Here the method in HTTP servlet request, the get the request dispatcher get request dispatcher string path returns a request dispatcher object that acts as a wrapper for the resource located at the given path. A request dispatcher object can be used to forward a request to the resource or to include resource in response. The resource can be dynamic or static. As an example 7, we can consider interface servlet config. A servlet a servlet configuration object used by a servlet container to pass information to a servlet during initialization. This is in module Jakarta.servlet and in package Jakarta.servlet. We can, as an example 8, we can consider servlet mapping example here. This is in file web.xml. With regarding configuring servlets, you define servlet as part of the web application in several entries in J2EE standard web application deployment descriptor web.xml. The web.xml file is located in the web dash inf directory of your web application. This one is basically, here we are talking about WebLogic server. The first entry, the web.xml file is located in web-inf directory of your web application. This is regarding WebLogic server. The first entry under the root servlet element in web.xml defines defines a name for the servlet, and specify the compiled class that execute the servlet. Or instead of specifying servlet class, you can specify JSP also. You can specify JSP. The servlet element also contains definition for initialization attributes and security roles for the servlet. The second entry for in the web.xml under servlet mapping element defines the URL pattern that calls the servlet. Here this do filter is belongs to filter chain method, filter chain here, and this is these are two different methods. So here as an example 10, create the following entry for the filter tag in the deployment descriptor file web.xml. Here this filter would apply to all JSP because we specified / asterisk in our configuration here. Here you can see we are now considering a servlet for the compiled JSP page. Here you can see the servlet code only depends on the JSP 3.1 and servlet 6.0 API as follows. As an alternative, the JSP page is compiled into an servlet with some implementation dependent name com.acme. Here underscore JSP underscore hello world underscore xxx underscore impl. The servlet code only depends on the JSP 3.1 and servlet 6.0 API as follows. Page context, create initial JSP writer out. Example, we can consider class servlet exception defines a general exception a servlet can throw when it encounters difficulty. This is in module jakarta.servlet and package jakarta.servlet. Now we are focusing on JSP pages. This is a view. A JSP page is a textual document that describes how to create a response object from a request object for a given protocol. The processing of the JSP page may involve creating and or using other objects. Now we are focusing on life cycle of JSP. A JSP page services requests as a servlet. Thus, the life cycle and many of the capabilities of JSP pages, in particular the dynamic aspects, are determined by Java servlet technology. When a request is mapped to a JSP page, the web container first checks whether JSP page servlet is older than the JSP page. If the servlet is older, the web container translates JSP page into a servlet class, and translate into a servlet class and compiles the class. During development, one of the advantages of JSP pages over servlets is that the build process is performed automatically. This is about translation and compilation. During the translation phase, each type of data in a JSP page is treated differently. Static data is transformed into code that will emit the data into the response stream. JSP elements are treated as follows. Directives are used to control how the web container translates and executes the JSP page. Scripting elements are inserted into the JSP page servlet class. Expression language expressions are passed as parameters to calls the JSP expression. JSP : set or get property elements are converted into method calls to Java Beans components. JSP : include or forward elements are converted into invocations of the Java Servlet API. The JSP : plugin elements is converted into browser-specific markup for activating an applet. Custom tags are converted into calls to the tag handler that implements the custom tag. The application server, the source for the servlet created from JSP page name in this file domain dir/generated/JSP/ j2ee-modules/var-name /page name _jsp.java. This is in Java Oracle version. Both the translation and the compilation phases can yield errors that are observed only when the page is requested for the first time. If an error is encountered during either phase, the server will return Jasper exception and a message that include the name of the JSP page and the line where the error occurred. After the page has been translated and compiled, JSP page servlet for the most part follows the servlet life cycle. If the instance of the JSP pages servlet does not exist, the container loads the JSP pages servlet class, instantiates the instance of the servlet class, initializes the servlet instance by calling JSP init method, and the container invokes the _JSP service method passing request and response objects. And if the container needs to remove the JSP pages servlet, it calls the JSP destroy method. Execution, you can control various JSP page execution parameters by using page directives. Buffering, when a JSP page is executed, output returned to the response object is automatically buffered. You can set the size of the buffering using the page directive greater than percentage mark at sign page buffer equal, for example, none, or xxxxb kb $sign less than. A larger buffer allows more content to be written before anything is actually sent back to the client, thus providing the JSP page with more time to set appropriate status codes and headers or to forward to another web resource. The smaller buffer decreases server memory load and allows the client to start receiving more quickly. Handling JSP page errors. Any number of exceptions can arise when a JSP page is executed, to specifically that the web container should forward the control to an error page. If an exception occurs, including following page directive at the beginning of your JSP page, page and error page equal file name. This directive here the is error page equal true indicates that it is serving as an error page. This directive makes an object of the type javax.servlet.jsp.error data available to the error page so that you can retrieve, interpret, and possibly display the information about cause of the exception in the error page. Here request, if the request is first time, then it's is connected to the creation. It can be connected to the translation, compilation, loading, instantiation, and initialization are inside creation. Creation is connected to the request, and if then the request is not first time, the subsequent times is connected to, then it's connected to request here, and request is connected to the response, and request is connected to destruction. Now we are focusing on contracts between a JSP page and a JSP container. JSP page implementation class should use the JSP factory and page context classes to take advantages of platform specific implementation. A JSP page model. A JSP page is represented at execution time by a JSP page implementation object and is executed by a JSP container. A JSP page implementation object is a servlet. The JSP container delivers requests from a client to JSP page. Page implementation object and responses from to the JSP page implementation updates to the client. JSP page describes how to create response object. from the request object for a given protocol, possibly creating or using some other objects in the process. A JSP page may also indicate how some events are to be handled. In JSP 3.1, only init and destroy events allowed. Events are the allowed events. JSP container must render the JSP page for HTTP method get and post with identical responses. The response for head request to a JSP page must be identical to the response for the get request minus the response body. The behavior of JSP container is undefined for other methods. The protocol, the protocol seen by the web server, JSP container locates the appropriate instance of the JSP page implementation class and delivers the request to it using servlet protocol. A JSP container may need to create such a class dynamically from JSP page source before delivering a request and response object to it. Servlet class define the contract between JSP container and the JSP page implementation class. When the HTTP protocol is used, the contract is described by the HTTP servlet class. Most JSP pages use the HTTP protocol, but other protocols are allowed by this specification. JSP container automatically makes a number of server-side objects available to JSP page implementation object. The protocol seen by the JSP page author. The JSP specification defines the contract between JSP container and the JSP page author. This contract defines the assumptions an author can make for the actions described in the JSP page. The main portion of this contract is the underscore JSP service method that is generated automatically by the JSP container from the JSP page. The contract also describes how a JSP author can indicate that what actions will be taken when the init method and destroy the methods of the page implementations occur. In JSP 3.1, this is done by defining methods with the names JSP init and JSP destroy. In the declaration scripting element of the JSP page, the JSP init method if present will be called to prepare the page before the first request is delivered. Similarly, the JSP container can reclaim resources by used by the JSP page when the request is being when a request is not being serviced by the JSP page by invoking its JSP destroyed method if present. A JSP page author may not redefine servlet's method through declaration scripting element. The JSP specification serves names for methods and variables starting with JSP JSPX and JSPX in any combination of upper and lower case. The HTTP JSP page interface. The enforcement of the contract between JSP container and the JSP page author is aided by the requirement that Servlet class corresponding to the JSP page must implement jakarta.servlet.jsp.http JSP page interface or jakarta.servlet.jsp.jsp page interface if the protocol is not HTTP. If it is HTTP, jakarta.servlet.jsp.http JSP page interface. The JSP page implementation class. The JSP container creates a JSP page implementation class for each JSP page. Name of the JSP page implementation class is implementation dependent. The JSP page implementation object belongs to an implementation dependent named package. The package used may vary between one JSP and another, so minimal assumptions should be made. As of JSP 2.0, it is illegal to refer to any classes from the unnamed, also known as default package. This will result in translation error. This restriction also applied for all other cases where classes are referenced, such as when specifying the class name for a tag in a TLD. The JSP container may create the implementation class for a JSP page, or a superclass may be provided by the JSP page author through the use of the extent attribute in the page directive. The extent mechanism is available for sophisticated users. It should be used with extreme care, as it restricts decisions that a JSP container can make. It may restrict efforts to improve the performance. For example, the JSP page implementation class will implement jakarta.servlet.servlet, and requests are delivered to the class as per the rules in the Servlet 6.0 specification. A page implementation class may depend on support classes. If the JSP page implementation class is packaged into a var, any dependent classes will have to be included, so it will be portable across all JSP containers. A JSP page author writes a JSP page expecting that the client and the server will communicate using a certain protocol. The JSP container must generate that request to and responses from the page that use protocol. Most JSP pages use HTTP, and the implementation class must implement the HTTP JSP page interface, which extends JSP page. If the protocol is not HTTP, then the class will implement an interface that extends JSP page. API contracts. The contract between JSP container and the Java class implementing JSP page corresponds to the servlet interface. Responsibility for adhering to this contract rests on the JSP container implementation if the JSP page does not use extend attribute of the JSP directive. If it extend attribute of the JSP directive is used, JSP page author must generate that the superclass given in the extend attribute supports this contract. Here is how the JSP contract processes JSP pages. Void JSP init. The method is optionally defined in the JSP page. Method is invoked when the JSP page is initialized, and when the method is called, all the methods in the servlet, including get service, servlet config, are available. Void JSP destroy. The method is optionally defined in the JSP page. Method is invoked before destroying the page. Void underscore JSP service, servlet requested subtype, servlet response subtype. Method may not be defined in the JSP page. The JSP container automatically generates this method based on the content of the JSP page. Method invoke at each client request. Request and response parameters. The methods in the contract between JSP container and the JSP page require request and response parameters. The formal type of the request parameter, which this specification calls servlet request subtype, is an interface that extends jakarta.servlet.servlet request. The interface must define a protocol dependent request contract between the JSP container and the class that implements the JSP page. Likewise, the formal type of the response parameter, which is specification called servlet response subtype, is an interface that extends jakarta.servlet.servlet response. The interface must define a protocol dependent response contract between the JSP container and the class that implements the JSP page. The request and response interfaces describe the protocol dependent contract between JSP container and the class that implements the JSP page. The HTTP contract is defined by jakarta.servlet.http servlet request and jakarta.servlet.http servlet response interfaces. The JSP page interface refers to these methods but cannot describe synthetically the methods involving servlet request response subtypes. However, the interfaces for specific protocols that extend JSP page can just as HTTP JSP page describe them for the HTTP protocol. JSP containers that confirm this specification, both the JSP page implementation classes and JSP container runtime, must support request and response interfaces for HTTP protocol. With regarding omitting the extends attribute, by using separate _JSP1344 and for example HTTP superclass, the JSP page translator does not need to discover whether JSP page includes declaration with JSP init or JSP destroy. And using the extend attribute, if the JSP page author uses extends, the generator class is identical to the one then except that the class name is not specified in the extend attribute. The contract on the JSP page implementation class does not change. The JSP container should check, usually through reflection, that the provided superclass implements HTTP JSP page if the protocol is HTTP or JSP page otherwise. If the protocol is HTTP, the EC should implement HTTP JSP page. All the methods in the servlet interface are declared final. Additionally, it is the responsibility of the JSP page author that the provider superclass satisfies the service method of the servlet API, invokes the _JSP service method. The init servlet config method stores the configuration that make available via get servlet config, then invokes JSP init. The destroy method invokes JSP destroy. The JSP container may give a fatal translation error if it detects that the provided superclass does not satisfy this requirement, but most JSP containers will not check them. Here you can see a JSP container is here, and init event is passed to JSP init, and request is passed to _JSP service, and JSP service is connected to response. Destroy event is passed to JSP destroy, and here you can see the JSP page, and this is the request processing page, and this is translation page. This is request processing and translation here. Here you can see a overview of Jakarta server pages, JSP page in a web application. A simple page. A simple page consists of HTML markup embedded with JSP tags. JSP files have the .jsp extension. The JSP server, also called JSP container, is configured to direct the HTTP request to a specific JSP page, which is responsible for rendering an HTTP response. When a request is arrived, the file is processed on the server and the HTML is rendered as application view, a web page. The embedded JSP tags will be used to call server-side code and data. Ultimate product of the JSP is a vanilla HTML that the client browser can understand as is. This diagram shows the interaction between HTML, JSP and web application server. Here you can see server code and data interacts with JSP tags. JSP tags are inside HTML here. Here you can see JSP resolver hierarchy. The EL API, the expression language, EL API provides a generalized mechanism for and EL resolver implemented by the JSP container, and which define the rules that govern the resolution of variables and object properties. EL resolver shown in this figure is passed to all EL expressions that appear in an JSP page or tag file. It is an instance of jakarta.el.composite resolver that contains the following component: EL resolvers in order. One, the JSP implicit object resolver, implicit object EL resolver resolves the implicit objects to the EL resolvers added via JSP application context add resolver. Add EL resolver in the same order which they were registered. This itself can take the form of EL.composite EL.composite EL resolver. This will include EL resolver registered by phases. See, EL resolver returned by expression factory get EL resolver. Sorry, EL resolver returned by expression factory get stream EL resolver. For jakarta.el.static field resolver. Five, jakarta.el.map EL resolver. Constructed in read-write mode. Jakarta EL.resource bundle EL resolver. Jakarta.el.list EL resolver constructed in read-write mode. Jakarta.el.array EL resolver constructed in read-write mode. Jakarta.el.bean EL resolver constructed in read-write mode, handles all cases where base not equal null. JSP.scope attribute EL resolver handle cases where base equal null, base double equal null. Provide the map for other identifiers by looking up its value as an attribute according to behavior of page context.find attribute string on the page context object. For example, $sign open curly brace product close curly brace. This expression will look for the attribute named product, search the page, request, session and application scopes, and will return its value of if the attribute is found. JSP.import EL resolver handle cases where base equal null and base double equal null, and property represents the represent an imported class or static import. JSP.not found EL resolver always resolve the requested value, returning null. Here you can see EL.composite resolver. Under that ESP.implicit object EL resolver and EL.composite EL resolver and EL.map EL resolver, EL.resource bundle EL resolver, EL.list EL resolver, EL.array EL resolver, EL.bean EL resolver, EL.scoped attribute EL resolver, JSP.scope attribute EL resolver, JSP.import EL resolver, JSP.not found EL resolver. Under EL.composite EL resolver, you can see JFSS EL.composite EL resolver and other EL resolvers added via JSP application context.add EL resolvers. Under EL resolver, under JSFS EL.composite resolver, you can see JSF.implicit object EL resolver, JSF.manage bean EL resolver, EL resolvers in face-config.xml, JFS.variable resolver chain wrapper, so supports legacy JFS variable resolvers. JFS.property resolver chain wrapper supports legacy JFS property resolvers. EL resolvers from application.add EL resolver. Here you can see JSP elements. In the web application design JSP pages, we have to use the following element here. JSP directives. In web applications, JSP directives can be used to define present JSP page characteristics, to include the target resource content into the present JSP page, and to make available user-defined tag library into a present JSP page. All the JSP directives are going to be resolved at the time of translating JSP page into the servlet. The majority of JSP directives will not give a direct effect to response generation. JSP actions. In JSP applications, scripting elements are often want to allow Java code inside JSP pages, but the most theme of JSP technology isn't to permit Java code inside JSP pages. In the above context, to preserve the theme of the JSP technology, we have to eliminate scripting element from JSP pages. For this, we have to supply alternative, that is JSP actions provided by JSP technology. In the case JSP actions, we will define a scripting tag in situ of the Java code in the JSP pages, and that we will provide the respective Java code inside the classes folder. In this context, when the JSP container encounters the scripting tag, then the container will execute the respective Java code and perform specific action called JSP action. JSP scripting element. In web application, JSP scripting elements are often want to provide code in JSP pages. All JSP script elements are going to be resolved at the time of request processing. The majority of scripting elements will give a direct effect on response generation. JSP scripting elements enable you to insert Java code directly into the servlet that will be generated from the current JSP page. There are three types of scripting element: declarations, declaration of the form of that is inserted into the body of the servlet class outside of any existing method; scriptlets, scriptlets of the form that are inserted into the servlet service method; expressions, expressions of the form that are evaluated and inserted into it. JSP declarations, it is often want to provide all the Java declarations like variable declarations, method definitions, class declarations, and so on. A declaration can consist either method declarations or variables. Static constants are a good example of what to put in the declaration. JSP you write turns into a category definition. All scriptlets you write are placed inside one method of this class. You can also add variable and method declarations to present class. You can then use these variable and methods from the scriptlets and expressions. You can use declaration to declare one or more variables and methods at the category level of the compiled servlet. In fact, they are declared at the class level rather than the body of the page is significant. The class members, variables, and methods can then be employed by Java code within the remainder of the page. When you write a declaration during a JSP page, remember these rules. First must be ended with declaration with the semicolon. Open greater than sign, dollar sign, int I equals 0, semicolon, greater dollar sign, less than sign. For example, we can use variables and methods that are declared in the package imported by the page directive without declaring them in a declaration element, and we can declare any number of variables or methods within the one declaration element as long as the end of declaration with the semicolon. Declaration must be valid in the Java programming language. If you offer any Java declaration by using declaration scripting element, then each one of the declarations are going to be available to the translated servlet as class level declarations. JSP scriptlets, this scripting element often want to provide a block of Java code. It can contain any number of language statement, variables, and method declarations or expressions that are valid within the page scripting language. Within a scriptlet, you can do following. One, on the JSP page, declare variables or method to use later. Write valid expressions in the page scripting language. Use any of the implicit objects or any object declared with the element. On the JSP page, write any other statement valid in the scripting language used. All text, HTML tags or JSP element you write must be outside the scriptlet. If we offer any block of Java code by using scriptlets, then that code is going to be available to translate service servlet inside underscore JSP service method. This code placed in the scriptlet goes to the underscore JSP service method of JES class as it is. The code is useful as request processing logic to process the request. Variables declared in the scriptlet becomes a local variable of underscore JSP service. All implicit objects of JSPs are local variables of underscore JSP objects with JSP service method. And the code of the scriptlet also goes underscore JSP service method. So we can use implicit object in scriptlets. We cannot place method definitions in JSP because they become the nested method of underscore JSP method, and Java does not support nested methods. JSP expressions. This is a scripting element. This scripting element I often want to evaluate the only Java expression and display that expression resultant value on the client browser. The expression element contains a Java expression and returns a worth. This value is often this value is then returned to the HTML page. The expression tag can contain any expression that's valid constant with the Java language specification. This include variables, method calls, then return values. So any object that contains this toString method. It evaluates the given expression displayed generated result into the browser windows. Anything that return a result is called an expression. If we want, if we provide any Java expressions in expression scripting elements, then that expression will be available to translate servlet code underscore JSP service method as a parameter to out.write method. If the expression tag is used perfectly when there is no need of using out.println on the JSP page, the code placed in the expression tag goes to the underscore JSP service method of GES class. So we can use implicit object in expression tag. We can use the expression tag for instantiation and display data of the object. We can use the expression tag to call both user-defined and predefined method, which returns results. Here the Java expression is evaluated and then converted to string and inserted in the page. This evaluation is performed at runtime when the page is requested, and thus has full access to the information about the request. Here you can see JSP elements are connected to JSP directives and scripting element and JSP actions. In JSP directives are connected to page, include, and taglib. Scripting elements are connected to a declaration, scriptlets, expressions, and comments, and JSP actions are connected to standard actions and custom actions. Here we are considering JSP tags. The embedding of Java code in HTML pages. It is a more easier approach to create and maintain web application than servlets. Servlets put HTML code inside the Java code, while JSP adds the Java code inside HTML. JSP can do everything that the servlet can, but JSP is more easier approach. Java server pages are the Java platform technology for delivering dynamic content to web client in the portable, secure, and well-defined way. It is an extension to the servlet because it provides more functionality than servlet. The JSP page contains HTML codes and JSP tag. JSP pages are easier to maintain than servlets because we can separate designing and development. It provides additional features such as expression language, custom tags, implicit object, predefined tags, etc. Web content is responsible for convert JSP pages to servlet. Here you can see some tags and JSP. Here presentation, JSP standard tag, and custom tags. In JSP standard tags, you can see directive tags, standard action tags, and scriptlet tags. Under directive tags, you can see page directive, include directive, tag lib directive. Standard tags, forward action, include action, use bean action. Standard action tags, and scriptlets here, scriptlet tags, expression tags, declaration tags. Here you can see tags and its life cycle. To design tag handler classes in custom tags preparation, JSP API has provided some predefined library in the form javax.servlet.jsp.tag.ext package, tag.ext, then tags extension. The tags ext for means tag extension. The servlet.jsp.tag extends package has provided the following tag library to design tag handler classes. Here body tag implements body tags. Here the as per tag library provided by JSP technology, there are two types of custom tags, classic tags and simple tags. Classic tags in JSP, the classic tags are custom tags that implements the JSP implements the JSP.tag ext.tag interface. There are three types of classic tags: simple classic tag, iterator tags, and body tags. Simple classics, simple classic tags in JSP, it is designed on the basis of classic tag library provided by JSP API. The servlet.jsp.tag ext.tag support is its sub interfaces and override classes which has default implementation. Simple classic tag does not have a body and attribute list. To design simple classic tag, the respective tag handler class must be implement the tag interface either directly or indirectly. Iterator tags in JSP, to prepare iterator tags in the respective handler class must implement the iteration tag interface. It retrieves the object stored in Java Beans components and assign them to variable and then body. The body of the tag retrieves information from that variable. Iteration tag causes the body to be evaluated as long as elements remain in the collection. Tag support class. Tag support class is a concrete class which has implemented tag and iteration tag interfaces with the default implementation. If we want to prepare custom tags with the tag support class, then we have to take user defined class, which must be a subclass to tab support class. Body tags in JSP to perform updates our custom tag body. We have to use body tags to design body tags in JSP technology. Then the respective tag handler class must implement body tag interface. It provides the body tag support class which provide the default empty methods defined in the interface. A simple tag in JSP, in the case of a simple tag library, all the tag handler class objects are non-cacheable objects and all the custom tags are having body tags capacity by default. To design simple tags by using simple tag library, the respective tag handler class must implement the tag interface. The simple tag are as capable as classic tag, but simple tags we cannot include scripted code in the body of a simple tag. Simple tag support class to design a custom tag using simple tag support class. Then the respective tag handler class must be extended from simple tag support class, where we have to override the required field. Here the class body tag support in package jakarta.servlet.jsp.tag.ext and in module jakarta.servlet.jsp. The base class for defining tag handlers, implementing body tag. Interface body tag. The body tag interface extend iteration tag by defining additional methods that let the letter tag handler manipulate the content of evaluating its body. Iteration interface iteration tag. The iteration tag interface extend tag by defining one additional method that control the re-evaluation of its body. Here the interface tag. The interface of the class tag handler that does not want to manipulate its body. The tag interface defines the basic protocol between a tag handler and JSP page implementation class. It defines the lifecycle and method to be invoked at start and end tag. Interface JSP tag serves a base class for tag and simple tag. This is mostly for organizational and type safety purposes. Interface simple tag. Interface for defining simple tag handlers. Class simple tag support, a base class for defining tag handlers implementing simple tag. Here body tag support class implements body tag. Here body tag extends iteration tag interface. Here the iteration tag class implements iteration tag, and iteration tags extend tag interface, and tag interface extend JSP tag, and here simple tag support class implements simple tag, and simple tag extend JSP tag interface. Here you can see the relationship between JSP pages and XML views of JSP pages. If we consider overview of JSP documents and XML views, the JSP document is a JSP page written in XML syntax. JSP document need to be described such either implicitly or explicitly to the JSP container, which will then process them as XML documents, checking for well-formedness and applying requests like entity declarations. If present, JSP documents are used to generate dynamic content using standard JSP semantics. To design JSP document is focused on generation of dynamic XML content and in any of its many uses, but JSP documents can be used to generate any dynamic content. The alternate some synthetic elements are there. The alternative syntaxes can be used in JSP documents. Most of them JSP : output and JSP : root are exceptions. Can also be used in JSP pages in JSP syntax, as it will be JSP document can be used in a number of ways, including JSP documents, can be passed directly to the JSP container. This is becoming more important as more and more content is authorized as XML, but in an XML based language like XHTML or SVG, or for the exchange of document in application like web services. The generated content may be sent directly to the client, or it may be part of some XML processing pipeline. JSP documents can be manipulated by XML aware tools. The JSP documents can be generated from textual representation by applying XML transformation like XSLT. JSP document can be generated automatically, say by serializing some objects. The tag files can also be authorized by using XML syntax. The rules are very similar to JSP documents. The XML view of JSP page is an XML document that is derived from JSP page following mapping defined later following mapping. The XML view of a JSP page is intended to be used for validating JSP page against some description of the set of valid pages. Validation of JSP page is supported by the JSP 3.1 specification through tag library validator class associated with the tag library. The validator class acts on a page data object that represents the XML view of the JSP page. This figure depicts the relationship between concepts of JSP pages, JSP documents, and XML views. Two phases are involved. The translation phase, where JSP pages in either syntax are exported to tag library validators via their XML view, and the request processing phase, where requests are processed to produce responses. JSP documents are used by JSP page authors. They can be authorized directly using a text validator through XML editing tool or through a JSP page authoring tool that is aware of XML syntax. Any JSP page author that is generating XML content should consider the use of JSP document. In contrast, the XML view of a JSP page is concept internal to the JSP container and is of interest of only to tag library authors and to implement JSP containers. Here you can see JSP pages, JSP syntax and XML syntax. JSP syntax and XML syntax is connected to XML view. It is in the now we are in the translation phase. TLV1 errors OK and TLV2 errors OK, and XML is connected to JSP implementation class. Here we are in the request processing phase, and request connected to the request is connected to JSP implementation, and response is produced from JSP implementation class. Here you can see life cycle of JSP pages. The life cycle of life cycle of a JSP page. The life cycle of a JSP is shown here. The most important fact about this figure is that all JSPs are managed by JSP containers and compiled into servlets before they are loaded. Similar servlets and same instance is used to all requests. Similar servlets and same instance is used to all requests since JSP is compiled into a servlet. Here the receive request, page compiler servlet, JSP's page servlet, and send response is inside JSP container. Receive request is connected to JSP servlet exists. If it is yes, then JSP servlet is loaded, and if, then check the is JSP servlet loaded. It's yes, then it's moved to generate response. If it is not, it's move to load servlet. If the JSP servlet exists is no, then it's passed to fast JSP, then it's connected to generate JSP servlet source, then it's connected to compile JSP servlet, then it's connected to load servlet, and load servlet is connected to generate response in JSP page servlet, and then generate response is connected to send response. Here you can see the basic tag lifecycle. This UML resequence diagram shows how a page implementation class calls the method of a tag handler class. Although the simple tag interface supplies the contract that must provide, interfaces in Java cannot specify the order in which operations are called. This information is instead specified with the JSP specification. This figure shows the order in which the tag methods are called when the tag is evaluated. With classic tags, one of the most complex pieces of tag lifecycle is how the tag handler instance can be pulled by the container. And reused. Although this tend to increase performance and reduce the number of object instantiations that occur, the semantics for reusing tag handlers often causes confusion and hence side effects from the misunderstanding of the tag lifecycle. Therefore, simple tags are used once and only once before the tag handler reference is discarded. In other words, each simple tag invocation causes creation of a new tag handler instance, therefore greatly simplified the programming model. Creating a tag handler instance, when custom tag is used on JSP page, the first thing that the JSP container must do is creating a new instance of the tag handler class. Setting the context. Next, the tag handler instance is made aware of the environment in which it's running through the set JSP context method. This just involve passing reference to current current JSP context into a tag handler. One of the useful classes available to JSP developers is page context. From the javax.servlet.jsp package, this is available from a JSP page as an implicit object called page context. It is effectively provided as a convenient way to access various objects that are used in during JSP development. For example, page context class provide an easy way to access attributes that are bound to any of the available scopes: request, page, session, and application. It can also get reference to the current output JSP writer and programmatically include forward request. Although these features are available through the standard JSP actions or the JSP EL, the power behind the page context class is that it can be used within custom tags. One of the changes to JSP API that occurred with JSP 2.0 is that some of the functional functionality previously provided by JSP context class has abstracted away into a new class called JSP context, which page context now extends. This new base class provides all the functionality that is not directly related to the Java Servlet API, including methods that allow you to develop a perspective. Having access to this sort of information and executed environment means that you can write tags utilizing values from the request page, session, and or application, and write output from the tags directly back to the JSP page. You will see some examples back to the page. Setting the parent. During our discussion of body content types, you saw that it's possible for a body content of a custom tag to contain regular JSP syntax between start and end tags. This body content can include custom tags, which means that a custom tag can be nested. The part of the information about tags execution environment include reference to the closest enclosing tag handler, which is set by the set parent method. This reference is of the type JSP tag, the super interface of all tag handlers, but can be null if the tag is nested within another tag. Setting body content. After context has been set, an object representing the body content of the tag passed to it. At runtime, JSP container wraps up the body content between the start and end tags, create JSP fragment object to represent it, passes the JSP fragment instance to the tag by calling set JSP body method. There's no body context between start and end tags. A null reference is passed to this method. You will see executing the functionality. Finally, with the context and body context is set, only thing left to do is execute the functionality that the tag handler embodies. This is achieved by the doTag method, and it's this method that contains the Java code responsible for actions performed by the tag. You can see here the interface JSP page in package Jakarta.servlet.jsp in module Jakarta.servlet.jsp. This JSP interface describes the generic interaction of that JSP page implementation class must specify. Pages that use JSP protocol are described by the JDP page interface. Interface simple tag. Interface for defining simple tag handlers. Void set JSP context in JSP context PC, called by the container to provide this tag handler with the JSP context for this invocation, and implementation should save this value. This is in the interface simple tag. Void set parent JSP tag parent. Set the parent of this tag for collaboration purposes. Void set JSP body, JSP fragment, JSP body. Provide the body of this tag as a JSP fragment object able to invoke 0 or more times by tag handler. Void doTag called by the container to invoke this tag. The implementation of this method is provided by the tag library developer and handles all tag processing, body iteration, etc. Here you can see the JSP page, and here the simple tag, then is creates, then it's connected. JSP page is connected to simple tag via set JSP context, and then it's connected to then it's connected to simple tag via set parent JSP tag, and then set JSP body, JSP fragment, and then do tag. Here you can see a tag lifecycle with attributes. The lifecycle of a simple tag with parameters. Introducing attributes into a custom tag does change the tag lifecycle slightly, because before the functionality of a tag can be executed, the do tag method, in the case of a simple tags, the attributes must be passed to the tag handler so that they can be used by the tag. The way the JSP specification allows this is through properties and setter methods of the tag handler class. Tag handler must have property and setter method for every attribute that it supports. Note the necessary for the tag handler to have property and setter method for every supported attribute is a requirement of previous versions of JSP specification, but with the introduction of dynamic attributes, this is not strictly true anymore. These setter methods can confirm the standard Java bean naming convention, meaning that to support the attribute called name of a string, the tag handler must declare a setter method with the following signature: public void set name string s. In this example, at request time, the value of the name attribute will be passed to the set name method. With this in mind, you can now see the supporting attribute alters the tag lifecycle. Here the tag has to an example, consider this custom tag. Here the tag has two attributes that are being specified. By looking at the tag lifecycle in this figure, you can see what happened behind the scenes. This diagram shows the setter methods for the attributes are called before do tag method is executed, and in the same order that the attributes appear within the usage of the tag, left to right. When it comes to implementing attributes in tag handler class, attributes setter methods typically store a copy of the attributes away in an instance variable ready for do tag methods in use. Here you can see the interface JSP page in package Jakarta.servlet.jsp in module Jakarta.servlet. JSP page interface describes the generic interaction that JSP page implement class must satisfy. Pages that are in the HTTP protocol are described by the HTTP JSP page interface. Interface simple tag, the interface for defining simple tag handlers. Here the method void set JSP context PC called by the container to provide this tag handler with the JSP context for this invocation. Set void set parent JSP tag parent sets the parent of this tag for collaboration purposes. Here set attribute 1 and here set attribute n. Set JSP body, JSP fragment, JSP body. Provide the body of this tag as a JSP fragment object able to invoke 0 or more times by tag handler. Void do tag created called by the container to invoke this tag. Here a JSP page is connected to here by create. Here you can see a simple tag page. JSP page is connected to a simple tag via set JSP context, then set parent JSP tag, then attribute 1, then set attribute n, then set JSP body, JSP fragment, then do tag. Here you can see tag lifecycle. This UML diagram shows the lifecycle of a classic tag in terms of calling sequence of the class tag methods. As you the lifecycle of a simple tag consists of a tag handler being created, contextual and environment information being passed to it, and finally do tag method being executed. This shows classic tags are two different in this respect. This is classic tag. Creating a tag handler instance. As with simple tags, when a classic tag is used on a JSP page, the first thing that the JSP container must do is to create a new instance of the tag handler class. Again, this is performed by invoking a default no argument constructor. Next step is in the tag lifecycle is to make the tag handler instance aware of the environment in which is running. This invokes passing the tag handler a reference to the current page context through a set page context method. Like JSP context, this method provides easy way to access other objects such as the current output writer and scope attributes. Notice here that it's a page context instance that get passed to the tag and not the JSP instance, as happens with the simple tags. This moves simple tags away from being dependent on services and features provided by Java Servlet API. Page context uses such features, whereas JSP context doesn't. However, the consistency and backward compatibility with easier versions of JSP specification, page context actually extend JSP context. Then setting the parent. Like simple tags, classic tags can be nested. As you will, it's possible for custom tags handlers to cooperate and communicate with one another. As an example, child nested tag may ask information from the parent tag. For reason, the set parent method is called and passes reference to the closest enclosing tag handler, or null if the tag isn't nested. For simple tags, this reference is of type JSP tag, the super interface of all tag handlers. But again, for classic tag, this reference is of type tag, the sub interface of JSP tag for backward compatibility. The executing functionality. uh, with the context set. The next thing is to do is execute the functionality provided by the tag with classic tags. Means calling do start. This means calling do start tag and do end tag methods. When you looked at how custom tags are being used on the page, you can show that they can be written along with the shorthand forms as follows: prefix colon my tag, then / prefix colon my tag, prefix colon my tag, likewise. Here you can see JSP page, interface JSP page in package Jakarta.servlet.jsp in module Jakarta.servlet. .jsp. The JSP page interface describes the generic interaction that the JSP page implementation class must satisfy. Pages that use the HTTP protocol are described by the HTTP JSP interface. Interface tag. The interface of a classic tag handler that does not want to manipulate its body. The tag interface defines the basic protocol between a tag handler and JSP page implementation class. It defines the lifecycle and the methods to be invoked at start and end tag. The method void set page context set the current page context. The set parent tag set parent void set parent tag t. Set the parent closest encoding tag handler for this tag handler. Do start tag. Int do start tag. Process the start tag for this instance. This method is invoked by JSP page implementation object. Do end tag. Int do end tag. Process the end tag for this instance. This method is invoked by JSP page implementation object on all tag handlers. And void release called on tag handler release state. The page compiler guarantees the JSP page implementation object will invoke this method on all tag handlers, but there may be multiple invocations in do start tag and do end tag in between. So here you can see JSP page and JSP tag. Here the JSP page is connected to JSP tag via set page context void, then set parent tag void, then do start tag int, and here then do end tag int, and then here release void. Here you can see this UML diagram shows how the do start tag and do end tag methods are called to evaluate tags. In the long format, you can simply write the start opening and end closing tags. In the shortened format, you combine them. Regardless of how you write them, both the do start tag method and do end tag method are called in a tag handler instance. This figure shows the tag lifecycle from a slightly different viewpoint, then illustrate how a do start tag and do end tag. Methods can also affect the tag lifecycle by values that are returned by them. Do start tag the doStart tag method is called when the starting tag is encountered on this page. Int doStart throws JSP exception. This method signature from the tag interface state that the primitive int value is to be returned. This signals to the JSP page what to do next. Two values can be returned from tag implementation interface: skip body and eval body include, which are defined as constant within tag interface. Returning skip body signals to the JSP page that the after doStart tag method has been called. The any body content for the tag should be ignored. For example, any body content such as JSP code, Java code, or content that would normally be output to the page is simply dropped. Following this proceeding process, do the do end tag method. On the other hand, returning eval body include from doStart tag method signals that any body content should be evaluated and output to the page. End tag, the end tag, the to do the do end tag method is called when the ending tag is encountered on the page. Again, regardless of whether the tag is written on the page by using the long or shortened format, int do tag throws JSP exception. This method also specify an integer return type, and the valid return types for this method are other two constants defined in the tag interface: skip page and eval page here. This return value signal whether the JSP container should continue evaluating rest of the JSP page. In reality, the skip page return value is rarely used because there aren't many circumstances in which you will want to actually stop the rest of the page from being processed. One such example might be a security tag that appears at the top of the JSP page and check whether the current user is authorized to see the contents of the page. The final method to be called as part of the tag lifecycle is the release method, and this method is called to ask tag handler to release the any state. It may be storing, and it's called on the tag handler only when the tag handler instance is finished and won't be used anymore. In other words, JSP content that don't support optional pooling of tag handler instance, the release method is called after the do end tag method, because this particular instance will never be used again. In the other hand, the containers that provide instance pooling, this method is called only when the container has finished using the instance and before it gets garbage collected. Caution: it's the most common misconception. Release is always called directly after do end tag method, hence is used to clear the values of the instance variable. This is not the case, and relying on this behavior means that your tags might not work as expected on all vendors JSP containers. Here you can see the int doStart tag method in tag interface. The process start tag for this instance. This method is invoked by the JSP page implementation object. Here you can see eval body the static final int eval body include evaluate body into existing out stream valid return value for do start tag. Here the static final int skip body evaluation valid return value for do start tag and do after body. Here the int do end tag possess end tag for this instance. This method is invoked by JSP page implementation object on all tag handlers. Eval page static final int eval page continuing evaluation page valid return value for do end tag. Skip page of int static int static final int skip page, skip the rest of the page valid return value for do end tag. Here started and then connected to initialize context and attributes. It is connected to do start tag method, and then if it is it's connected to evaluate body where eval body include, and evaluate body is connected to do end tag method. Do start tag method is connected to do end tag method by skip body. Do start tag then it's connected to evaluate rest of the page via eval page here, and do start then it's connected to end, and here the eval page do end tag is connected to end via skip page. Here you can see the iteration tag life cycle. To support iteration, do after body method is called after do start tag. The return value of do after body indicates whether the tag body is evaluated again and or processing continues to the do end tag method. This figure illustrates the iteration tag lifecycle and shows where the new do after body method fits in with the lifecycle of a custom tag. Setting the context. As before, the first thing that happened is that the contextual information, the page context, and parent tag is passed to the tag handler instance. The start tag, after context has been set, the do start tag method is called, and one of the two things can happen. First, do start tag method can return skip body, meaning that the body content is ignored and proceed to the end tag method as before. Alternatively, a value of eval body include can be returned from the do start tag method, signaling to the JSP container that the body content should be evaluated and included in the page. Again, this is the same as with the tagged interface, although it's after the body content has been evaluated that things start to change. After the body content has been evaluated, the new do after body method is called. The primary purpose of which is to determine whether the body content should be re-evaluated. If this is the case, the method should return the eval body again. Construct defined within the iteration tag interface. On the other hand, when no more evaluation of the body content should happen, the skip body value should be returned. the end tag finally, regardless of whether or not the body was evaluated and re-evaluated multiple times, the do end tag method is called in the same way as the other tags that have been seen in this here. Again, possible values are the eval page and skip page. Here the int do start tag throws JSP exception. The start tag for this instance, this method is invoked by the JSP implementation object. Eval body in static final int eval body include evaluate body into existing out system valid return value for do start tag. And skip static final int skip body evaluation valid return value for do start tag and do after body. Int do after body throws JSP exception. The process body re-evaluation. This method is invoked by the JSP page implementation object after every evaluation of the body into the body evaluation object. This method is invoked if there is no body evaluation. Static final int eval body again request the re-evaluation of some body. Return from the do after body. For compatibility with JSP 1.1, the value is carefully selected to be the same as the now deprecated body tag dot eval body tag. Static final int skip body evaluation valid return value for do start tag and do after body. Int do end tag throws JSP exception. Possess the end tag for this instance. This method is invoked by the JSP page implementation object on all tag handlers. Static final int eval page continue evaluating the page valid return value for do end tag. Static final int skip page skip the rest of the page valid return value for do end tag. Here the in the starting initialize is connected to initialize context and attribute. It is connected to do start tag. Then it's if it is the value is eval body include, then it's do start tag is connected to evaluate body via eval body include. Evaluate body is connected to do after body method. Do after body method is connected to eval body via eval body again, and do after body is connected to do end tag via skip body, and do start tag is connected to end tag via skip body here, and end tag is connected to evaluate rest of page via eval page, and end tag is connected to end via skip page, and eval rest is connected to evaluate rest of page is connected to end here. Here you can see the eval body tag life cycle. The life cycle of a tag handler that implements the body tag interface here. So this figure summarizes the tag life cycle. Setting the context. As with all the other classic tags, first the contextual information, the page context and parent tag is passed to the tag handler instance. Start tag. After context has been set, the do start tag method is called, and with the body tag interface there are three different return values. As before, the do start tag method can return skip body, meaning that the body content is ignored and proceed to the do end tag method, or it can return eval body include signaling that the body content should be evaluated and included in the page. The difference is that the do start tag method can now return the eval body buffered context defined in the body tag interface. Returning this value indicates to the JSP container that you want to use the features provided by the body tag interface, especially that the tag handler will manipulate the body content. Setting the body content. Assuming that you return eval body buffered from the do start tag method to indicate that you want to manipulate the body content, the set body content method is called on the tag handler so that the tag can hold on to the body content reference and use it later. As you may remember from the before, the simple tag have a similar method called set JSP body method that passes JSP fragment instance representing the actual body of the tag. With the body tag interface, this process is slightly different. Instead of being passed the JSP fragment representing the body content that can subsequently invoke, the tag handler is passed an object of type body content. Throughout our look at the classic tag, generating content was simply a matter of finding the JSP writer instance associated with the page and outputting the content. The body content class is a subclass of JSP writer and can be thought of as a temporal sketchpad area to which content can be written. Behind the scenes, when the JSP container calls the set body content method, the regular output stream, the JSP writer is swapped out for the body content object, the same one that gets passed to the tag. This means that the any content output from this point onward until the end tag is reached actually return to the temporary sketchpad, not to the page. The JSP container then called the do init body method, which can then be used to set up any state before the body content is eventually evaluated. The effect of replacing the original JSP writer is that when evaluated, when any content between the start and end tags has also be returned to the body content object, providing you with the way to access generated content with manipulate it later. After the body, as with the iteration tag interface, the do after body method is called after the body content has been evaluated. There are no changes here. The method should return eval body again, or skip body do to signal whether the more evaluation of the body content are required. End tag the finally, regardless of whether or not the body was evaluated and re-evaluated multiple times, the do end tag method is called in the same way as the other tags you have been seen in this chapter. Again, possible return values are eval page and skip page, skip body, eval page and skip page. At this point in the life cycle, all of the body content has been evaluated and output into the body content object. The temporary sketch pad. With this in mind, you can now take this content and manipulate, transform it. When you are done, you can then write the final result to the original JSP writer interface. Here the method int do start tag throws JSP exception. The process start tag for the instance. This method invoked by the JSP page implementation object. Static final int eval body buffered. The request the creation of new buffer, the body content on which to evaluate the body of this tag. Return from the do start tag when it implements body tag. This is an illegal return value for do start tag when the class does not implement body tag. Eval body include static final int eval body include evaluate body into existing out string, valid return value for do start tag, this one, and static final int skip body evaluation, valid return value for do start tag and do after body. Void set body content set the body content property. This method is invoked by the JSP page implementation object at once per action invocation. This method will be invoked before do init body. This method will not be invoked for empty tags or for non-empty tags whose do start tag method return skip body or eval body include. Void do init body. Prepare for evaluation of the body. This method is invoked by JSP page implementing objects after set body content and before the first time the bodies should be evaluated. This method will not be invoked for empty tags or for non-empty tags whose do start tags method returns skip body or eval body include. Int do after body. The process body's evaluation. This method invoked by the JSP page implementation object after every evaluation of the body into the body evaluation object. This method is not invoked if there is no body evaluation. Static final int eval body again. Request the re-evaluation of some body returned from do after body. For compatibility with JSP 1.1, the value is carefully selected to be the same as the now deprecated body tag dot eval body tag. Static final int skip body evaluation valid return value for do start tag and do after body. Static final int eval page continuing evaluating the page valid return value for do end tag, and here the skip page. Static final int skip page, skip the rest of the page valid return value for do end tag. Static final int skip body evaluation valid return value for do start tag and do after body. Int do end tag method possess end tag for this instance. This method is invoked by the JSP page implementation object on all tag handlers. Here start, it's connected to initialize context and attributes, and it is connected to do start tag method, and do start tag method is connected to set body content via eval body buffered, and set body content is connected to int body method, and it is connected to eval body. Here the do start tag is connected to eval body via eval body include. Evaluate body is connected to do after body method, and do after body method is connected to evaluate body via eval body again, and do after body is connected to do end tag via skip body, and do start tag is connected to do end tag via skip body. Do end tag is connected to evaluate rest of the page via eval page, and it is connected to the end, and do end tag is connected to the end via skip page. Now we're considering here try catch final interface. During the tag life cycle, there are several opportunities where can do catch or do finally might be called to handle an exception. The JSP specification guarantees that the do catch method will be called if an exception is thrown in the do start tag method. The tag body content or do end tag method. Additionally, if the tag handler implements the iteration tag or body tag interface, do catch method will be executed if the exception is thrown within the do after body. And do init body methods respectively. Something to notice is that the do catch method won't be called if an exception is thrown before the execution of the do start tag method. Perhaps when the context or attributes are being set, therefore it is best not to put any logic into attribute setter methods that may cause an exception to be thrown. If the exception should be propagated further up to the calling stack, perhaps the JSP error page do catch method can handle the exception as required and then subsequently rethrow the same or new exception. This is useful because there's no way to tell that tag handler class to catch only specific subclasses of exception in the same way you want you would when writing try-catch blocks in your code. Instead, the do-catch method handles all exception, and it's set to us as tag developers to decide which to handle and which to rethrow. Do finally method, when you write try-catch finally blocks in regular Java code, the finally blocks always get called regardless of whether an exception is thrown. Similarly, do finally method on tag handler will always get called. Although tag handlers are generally small components, there is still much that can go wrong, especially when you are dealing with the databases and remote objects such as enterprise Java beans. Implementing try-catch finally interface is the way to build tags that are better equipped to deal with such problems. It will make your tag libraries more robust and resilient to failure. With this in mind, let's now take a look at how you can deploy this resilient tag and make them available for use in the easiest possible way. You can refer the documentation for more information. Here the int do start tag, the process start tag for this instance. This method is invoked by the JSP page implementation object. Int do end tag possess the end tag for this instance. This method is invoked by the JSP page implementation object on all tag handlers. Do catch, the void do catch throwable t throws throwable in interface try catch final in package jakarta.servlet.jsp.tag.ext in module jakarta.servlet.jsp. Invoked if a throwable occurs while evaluating the body inside the tag or in any of the following methods: tag.do start tag method, tag.do end tag method, iteration tag.do after body method, and tag body tag.do init body method. Void do finally invoke in all cases after do end tag method for any class implementing tag, iteration tag or body tag. This method is invoked even if an exception occurred in the body of the tag or in any of the following method: tag.do start tag method, tag.do end tag method, iteration tag.do after body method, and body tag.do init body method. Start is connected to initialize context and attributes here, and initialize context and attributes connected to do start tag method, and do start tag method is connected to do catch via exception thrown, and do start tag is connected to evaluate body via eval body include, and do start tag is connected to do end tag via skip body, and evaluate body is connected to try do catch via exception thrown, and evaluate body is connected to otherwise do end tag, and do end tag is connected to try do catch via exception thrown, and do end tag is connected to do finally. Do finally is connected to evaluate rest of the page via eval page, and do finally is connected to end via skip page, and do catch is connected to do finally, and do finally is connected to eval rest of the page, and eval rest of the page is connected to end of the page. Eval rest of the page is connected to the end. As an example, we can consider jakarta.servlet.jsp module. As an example 2, we can consider package javax.servlet.jsp. So actually javax is the older version. So here jakarta.servlet.jsp, as an example, we are considering package jakarta.servlet.jsp. Classes and interfaces for the core JSP 3.1 API. This is in module jakarta.servlet.jsp. As an example 3, we can consider an instance of an implementation dependent subclass of page context abstract class can be created by JSP implementation class at the beginning of its underscore JSP service. Method via the implementation's default to default JSP factory. Actually, here is one example of how to use these classes. Here you can see page context, the class page context. Page context extends JSP context to provide useful context information for when JSP technology is used in the servlet environment. And here you can see initialized implicit variables for here you can see error pass URL is here, and this request response for the page context, and error pass URL here is needs session here, JSP writer.default underscore buffer. This is auto flush, is true here. And here you can see initialize implicit variables for scripting environment. And the body of the translated JSP is here. And here is a code example of a Java servlet which is supposed to handle logging request. It redirect the user to the home page if logging successful. Here you can see the in the HTTP server request get request dispatcher string path returns a request dispatcher object that acts as a wrapper for the resource located at the given path. The request dispatcher object can be used to forward the request to the resource, or include a resource in the response. The resource can be dynamically resource can be dynamic or static. Note that this kind of forward from servlet to JSP the URL on the web browser, the browser remains unchanged. It is the URL of the servlet, even we specify the JSP page. This is check logging here. So here As an example 5, the instead of writing Java code uh, that outputs HTML, JSP lets you to write HTML, but HTML that contains Java code. Here's a JSP file that outputs the same dynamic, I put dynamic contents here. Save this file to a file named date.jsp in your web app directory next to your index.html, for example. Now open the browser to date.jsp, and you should see like this. And when you visit the date.jsp file, here, for example, JettyServe automatically compiles it into a servlet class, which then works just like any other servlet. Note that this requires a Java server, so you can't upload .jsp file to any file host. It has to be a Java server. But now, instead of writing Java code that contains HTML, you can write HTML that contains Java code. This makes it much easier to write web page. We are considering JS as an example 6. We can consider this very simple JSP page. Here the main topic is packaging JSP pages. Here JSP page is delivered in a source form, for example. This is like to be the most common example, and in the another example, JSP page is compiled into servlet that uses only servlet 6.0 and JSP 3.1 API calls. The servlet is then packaged into a var with a deployment descriptor such that it looks as the original JSP page to any client. So we start with a very simple JSP page, hello world.jsp, for example here, and the JSP page package as a source var file if you want. The JSP page can be packaged into a var file by just placing it at location /hello world.jsp in a default JSP page exception matching. Will pick it up. You can use the normal web.xml file and the servlet for the compiled JSP page. As an alternative, we will show how one can compile the JSP page into a servlet class to run it in a JSP container here. The JSP page is compiled into a servlet with some implementation dependent name. com.acme. JSP _ hello world _xxx _impl. The servlet code only depends on the JSP 3.1 and servlet 6.0 APIs, and this is as follows. Here the web application descriptor is here. The servlet is made look as a JSP page with following web.xml. Finally, everything is packaged together into a var /web web dash ina /web dot xml and /ina classes com acme underscore jsp underscore hello world underscore xxx underscore impl dot class. Note that if the servlet class generated for the JSP page had depended on some other supported classes, they would have to be included in the var. As an example, we are considering interface JSP page in package jakarta.servlet.jsp in module jakarta.servlet.jsp. The JSP page interface describes the generic interaction that the JSP page implementation class must satisfy. Pages that use the HTTP protocol are described by the HTTP JSP page interface. Now we are considering module jakarta.servlet.jsp. Now we are considering generating HTML in what is a JSP page. A traditional application domain of the JSP technology is HTML content. The JSP page is a contextual document that describes how to create a response object from a request object for a given protocol. The processing of the JSP page may involve creating and or using the other objects. The JSP page defines JSP page implementation class that implements the semantic of the JSP page. With regard in generating HTML, a traditional application domain of the JSP technology is HTML content. The JSP specification supports well this use through a syntax that is friendly to HTML and XML. Through it is not HTML specific. For instance, HTML comments are treated no differently than other HTML content. The JSP standard tag library has specific support for HTML, though some specific custom actions. Now we are considering generating XML. An increasingly important application domain for JSP technology is dynamic XML content using formats like XHTML, SVG, and OpenOffice format, and in applications like content publishing and data representation and web services. The basic JSP machinery JSP syntax can be used to generate XML content. But it is also possible to tag a JSP page as a JSP document and get additional benefits. JSP document is an XML document. This means that a JSP document is well formed, structured document, and that this will be evaluated by the JSP container. Additionally, the structure will be available to the JSP validation machinery, the tag library validators. A JSP document is a namespace aware XML document with namespace reflecting the structure of both content and custom actions, and with some additional care, the JSP page can reflect quite accurately the structure of the resulting content. A JSP document can also use machinery like entity definitions. JSP 1.2 specification made a stronger distinction between JSP document and non-XML JSP pages. For instance, standard actions like JSP : expression were only available in JSP documents. The difference proved to be confusing and distracting, and distinction was relaxed in JSP 2.0 to facilitate the transition from JSP syntax to XML syntax. Now we are considering translation and execution phases. A JSP container manages two phases of the JSP page's lifecycle. In the translation phase, the container validates the syntactic correctness of JSP pages and tag files and determine a JSP page implementation class that correspond to the JSP page. The execution phase container manages one or more instances of this class and in response to the request and other event. During the translation phase, the container locates or creates a JSP page implementation class that corresponds to a given JSP page. This process is determined by the semantics of the JSP page. The container interprets the standard directives and actions, and the custom actions referring to tag libraries used in the page. Tag library may optionally provide a validation method acting on the XML view of the JSP page. JSP container has flexibility in details of the JSP page implementation class that can be used to address quality of service, most notably performance issues. During execution of phase of the JSP container delivers event to the JSP page implementation object. The container is responsible for instantiation request and response object and invoking appropriate JSP page implementation object. Upon completion of processing, the response object is received by the container for communication to the client. Translation of the JSP source page into its implementation class can occur at any time between initial deployment of the JSP page into the JSP container and the receipt of the processing of the client request for the target JSP page. Now we are considering validating ASP pages. All JSP pages, regardless of whether they are written in the traditional JSP syntax or XML syntax of JSP document, have an equivalent XML document, the XML view of a JSP page that is presented to tag library validators in the translation phase for validation. The structure of the custom actions in a JSP page is always exposed in the XML view. This means that the tag library validator can check that, for instance, some custom actions are only used within the others. The structure of the content used in a JSP page is exposed in greater or lesser details depending on whether the XML syntax or traditional JSP syntax is used. When using XML syntax, a tag library validator can use this extra structure to, for example, to check that some actions are only used with some content or within some content, and using knowledge of the semantics of the custom actions, make assertions on the generated dynamic content. Now we are considering events in JSP pages. As of JSP 1.2, only int and destroy events can be described in the JSP page. The void JSP init in interface JSP page, in package jakarta.servlet.jsp, in module jakarta.servlet.jsp. The JSP init method is invoked when the JSP page is initialized. It is the responsibility of the JSP implementation and of the class mentioned by the extent attribute, if present, that at this point invocations to the get servlet config method will return the desired value. A JSP page can override this method by including a definition for it in a declaration element. A JSP page should redefine the init method from servlet. A JSP page may indicate how some events are to be handled. As of JSP 1.2 only, init and destroy events can be described in the JSP page. When the first request is delivered to the JSP page, a JSP init method, if present, will be called to prepare the page. Similarly, the JSP container invokes JSP destroy method to reclaim the resources used by the JSP page at any time when a request is not being serviced. This is the same life cycle as for servlets. JSP configuration information. JSP pages may be extended with the configuration information that is delivered in the JSP configuration portion of the web.xml deployment descriptor of the web application. The JSP configuration information includes interpretation of the tag libraries used in the JSP files and different property information for groups of JSP files. The property information includes page encoding information, whether the EL evaluation and scripting machinery is enabled, and prelude and coda automatic inclusions. The JSP configuration information can also be used to indicate that some resources in the JSP web applications are JSP files, even if they do not conform to the default .jsp extension, and to modify the default interpretation for .jspx. Now we are considering naming convention for JSP files. A JSP file page is packaged as one or more JSP files, often in a web application. and delivered to a tool like JSP container, the Jakarta E container, or an IDE. The complete JSP page may be contained in a single file. In other cases, a top file will include the other file that contains complete JSP pages or include segment of pages. By default, the extension .jsp means the top level JSP file. It is common for tools need to differentiate JSP files from other files. In some cases, the tools also need to differentiate between top JSP files and include segments. For example, a segment may not be a legal JSP page and may not compile properly. Determining the type of the file is also very useful from the documentation and maintenance point of view, as people familiar with the .c and .h convention in C language know. By default, extension .jsp means the top level JSP file. We recommend but do not mandate to differentiate between top level JSP files invoked directly by the client or dynamically included by another page or servlet, and statistically include a segment so that .jsp extension is used only for files corresponding top level JSP files forming a JSP page when processed. Statistically include segment use any other extension, as included segments were called JSP segment in past versions of this specification. That extension .jspf was offered as a suggestion. This extension is still suggested for consistency reason, despite that they are now called JSP segments. JSP document, that is JSP pages that are delivered as XML document, use the extension .jspx by default. The JSP property group element of web.xml can be used to indicate some of the group of files, perhaps not using either of the extension above. JSP pages and can also be used to indicate which ones are delivered as XML documents. Now we are considering JSP page packaging in compiling JSP pages. When JSP page implementation class depends on support classes in the addition to the JSP 3.1 and Servlet 6.0 classes, the support classes are included in the package var as defined in the Servlet 6.0 specification for portability across JSP containers. The packaging of JSP pages contains two examples. For example, in JSP pages packaged in vars, a JSP page delivered in source form, most common case. Then 2 is the JSP page translated into implementation class plus deployment information. The deployment information indicates support classes needed and mapped between the original URL path to the JSP page and the URL for the JSP page implementation class for that page. Now we are considering debugging JSP pages. In the past, debugging tools provided by development environment have lacked a standard format for conveying source map information, allowing debugger for one vendor to be used with the JSP container of another. JSP 3.1 containers must support the Jakarta debugging support for other languages specification. Now we are considering elements and template data in synthetic elements of a JSP page. A JSP page has elements and template data. An element is an instance of an element type known as JSP container. Template data is everything else, that is everything that the JSP translator does not know about. The type of an element describes its syntax and semantics. If the element has attributes, the type describes the attribute names, their valid types and their interpretation. If the element defines object, the semantics include what objects it defined and other types. Now we are considering directives in element syntax. Directive element have a syntax of the form here. Directive provide the global information that is conceptually valid independent of any specific request received by the JSP page. They provide information for translation phase. The directive element have syntax of the form here. Now we are considering start and end tag. The same rule applies to the element in the alternative syntax. For example, scriptlet has the syntax here. Elements that have distinct start and end tags, which enclosed by, must start and end in the same file. The start tag cannot be in one file while the end tag is in another. The same rule applies to the element in the alternative syntax. For example, a scriptlet has syntax here. The both opening characters and enclosing characters here must be in the same physical file. Scripting language may also impose constraint on the placement of start and end tags relative to the specific scripting constructs. Now we are considering empty elements. As examples, the following are all empty tags here. Following the XML specification, an element described using an empty tag is indistinguishable from one using the start tag and empty body and an end tag. As examples, the following all are empty tags, while following all are non-empty tags. Attributes values, following the XML specification, attribute values always appear quoted. Either single or double quotes can be used to reduce the need for escaping quotes. There are two types of attributes values, literals and request time expressions, but the quotation rules are the same. Now we are considering the JSP colon attributes, attributes and JSP body and JSP element, JSP colon elements. Until JSP, here the both example have tags body contains simple words, template, text. Until JSP 2.0, the tag handlers could be passed into input two ways, through attribute values and through element and through element body. Attribute values were always evaluated once if they were specified as an expression. And the result was passed to the tag handler. The body could contain scripting elements and action elements and be evaluated to 0 or more times in the demanding tag handler. As of JSP 2.0, the page authors can provide input in new ways using JSP colon attribute standard action element. Based on the configuration of the action being invoked, that the body of the element either specify value that is evaluated once the JSP colon attributes action must only be used to specify attribute value for standard or custom actions, and translation error must occur if uh, 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 if it is used in any other context, for example, to specify the value of the template that look like an XML element. It is illegal JSP syntax which must result in translation error to use both an XML attributes and in JSP attribute standard action to pass the value of the same attribute. This example uses XML element attribute to define the value of the param1 attribute, and uses an attribute standard action to define the value of the this example uses XML element attribute to define the value of the parameter param1 here attribute, and uses the attribute standard action to define the value of the param2 attribute. In this example, the value of the param2 comes from the result of custom action invocation. If a page author wishes to pass both an attribute standard action and a tag body, the JSP the JSP column body standard action must be used to specify the body. A translation error will result if the custom action invocation has JSP attribute element but does not define the body using the JSP body element. The following example here shows two equivalent tag invocations to the hypothetical my tag colon format body custom action. The first invocation uses XML element attribute to pass the value of the color and size attributes. The second example uses an attribute standard action to pass the value of the color attribute. Both examples have tag body containing simply the words template text. The JSP attribute JSP colon attribute can be used with an JSP colon element standard action to generate dynamic content in a well structured way. The example here generates an HTML head of some type known at the page authoring time. Now we are considering valid names for actions and attributes. The names for actions must follow the XML convention, that is, must be in MN token as indicated in XML 1.0 specification. The names for attribute must follow the conventions described in the Java Beans specification. Attribute names start with JSP underscore JSP, Java and Jakarta are reserved in this specification. Now we are considering white space. the example 1 input is here. In HTML, XML and XML whitespace is usually not significant, but there are exceptions. For example, an XML file may start with character greater than question mark XML, and then it must do so with no leading whitespace characters. This is, in the specification follows the whitespace behavior defined for XML. Whitespace within the body text of a document is not significant but is perceived. The default behavior can be modified for JSP pages in standard syntax. Next, here are the two examples of JSP code with the associated output. Note that directives generate no data and apply globally to JSP page. Here the example 1 input, and the result is here. And the next two tables here shows another example with input and output. It is possible to have extraneous whitespace removed from the template text through element trim-directive-whitespaces of JSP property groups, or the page and tag file directive attributes trim directive whitespaces. JSP documents, the default convention for the JSP document is .jspx. A JSP page is usually passed directly to a JSP container. A JSP document is a page that is also an XML document. When a JSP document is encountered by the JSP container, it is interpreted as an XML document first, and after that as a JSP page. Among consequences of this are document must be well formed, validation if indicated, entity resolution will apply if indicated, greater than $sign the less than $sign style syntax cannot be used. The JSP documents are often a good match for a generation of dynamic XML content, as they can perceive much of the structure of the generated document. The default convention for JSP document is .jspx. There are configuration elements that can be used to indicate that the specific file is a JSP document. JSP syntax and grammar. In addition, the following notes and rules apply. Here we present a simple EBNF grammar for JSP syntax. The grammar is intended to provide the concise syntax overview and to resolve any syntax ambiguities present in the specification. Other sections may apply further restriction to this syntax. For example, restrict what represent a valid attribute value for a page directive. In all other cases, the grammar takes precedence in resolving syntax questions. The notation for grammar is identical to that described by other chapters in XML 1.0 specification available at the w3.org URLs. In addition, the following notes and rules apply. The root production for a JSP page is JSP page. The prefix XML is used, XML : is used to refer to an EBNF definition in the XML 1.0 specification. Where applicable to resolve grammar ambiguities, the first matching production must always be followed. This is commonly known as the greedy algorithm. if the translation error production is followed, the page is invalid and the result will be a translation error. The many productions make use of XML style attributes. These attributes can appear in any order separated from each other white space, but no attributes can be repeated more than once. To make these XML style attribute specifications more concise and easier to read, the syntax attr set is used in the EBNF to define a set of XML attributes that are organized in a particular production. Within the square brackets, attr set is listed comma-separated list of case-sensitive attribute names that are valid. Each attribute names represent a single XML attribute. If the attribute name is prefixed with the equal sign, the production attribute defined attribute must match either RT-EXPR value or static value accepted. If not, the production non-RT attribute must be matched. Only static values are accepted. If the attribute name is prefixed with the bang sign, the attribute is required and must appear in order for this production must be to be matched. If an attribute that matches the attribute production with the name not listed appears adjacent to any of the other attributes, the production is not matched. For example, consider the production that contain attr bang name equal value and not equal repeat. This production is matched if and only if all the following is true. The name attributes appeared exactly once and matches the non-RT attribute production. The value attribute appears at most once. If it appears, the attribute production must be matched. The repeat attribute appears exactly once and matches the attribute production. There must be no other attribute aside from the name value or repeat. Now we are considering packaging of JSP pages. A very simple JSP page. We are considering a very simple JSP page in packaging JSP pages. We start with a very simple JSP page, hello world.jsp. The JSP page package as a source in a WAR file. The web.xml is trivial. The JSP page can be packaged into WAR file by placing it at location /hello world.jsp. The default JSP page extension mapping will pick it up. The web.xml is trivial. Now we are considering the servlet for the compiled JSP page. The servlet code only depends on the JSP 3.1 and servlet 6.0 APIs as follows here. As an alternative, we will show how one compile JSP page into a servlet class to run a JSP container. The JSP page is compiled into a servlet with some implementation dependent name com.acme. Here the underscore JSP underscore hello world underscore xxx underscore impl. The servlet code only depends on the JSP 3.1 and servlet 6.0 APIs as follows. Page context create initial JSP write out. Now we are considering web application descriptor. The servlet is made to look as a JSP page with the following web.xml. The WR file for compiled JSP page, finally everything is packaged together into a WR file. WAR here note that if the servlet class generated for JSP page had dependent on some other support class, they would have to be included in WAR. Now we are considering JSP page or tag file in JSP page directive in JSP page or tag file in XML view of a JSP document in XML view. The page directive the page directive of the form like here. The JSP the page directive of the form is like here, is translated into an element of the form here. The value of page encoding attributes is set to UTF-8. The value of the content type attribute is set to the value of that container will pass to the servlet response dot set content type. The page directive and the both attributes are added if they don't exist already. Now we are considering validating an XML view of a JSP page. The validating an XML view of JSP page. The tag library validator for a tag library permits encapsulation this knowledge with the tag library. The class tag library validator in package jakarta.servlet.jsp.tag.ext in module jakarta.servlet.jsp. Translation time validator class for the JSP page. Validator operates on the XML view associated with the JSP page. The XML view of a JSP page is a namespace aware document. It cannot be validated against DTT except in a most simple cases. To reduce confusion and possible unintended performance consequences, the XML view of a JSP page will not include a doc type. There are several mechanisms that are aware of namespaces that can be based to do validation of XML views of JSP pages. The most popular mechanism is the W3C XML schema language, but others are also suited, including some very simple ones that may check. For example, that only some elements are being used for inversely that are not used. The tag library validator for a tag library permits encapsulation this knowledge with the tag library. The tag library validator act on XML view of a JSP page. If the page was authorized in JSP syntax, that view does not provide any details on template data, all being grouped inside JSP:text element, but the fine details can be described when using JSP documents. Similarly, when applying the XSLT transformation to a JSP document, the XML fragments will be plainly visible, while the content of JSP:text element will not. Here's a JSP document in examples. Here the JSP standard tag library is used. This is an example of very simple JSP document that has some template XML elements. This particular example describes a table that is a collection of 3 rows with numeric values 1, 2, 3. The JSP standard tag library is used is being used here. Now we are considering core syntax and error handling in core syntax and semantics. Using JSPs as error pages, a JSP is considered an error page if it sees the page directive is error page attributes to true. If the page has is error page set to true, the exception implicit scripting language variable of the page is initialized. The variable is set to the value of the Jakarta.server.error.exception request attribute value if the present, and otherwise to the value of the Jakarta.server.jsp exception request attribute for backward compatibility for JSP pages pre-compiled with the JSP 1.2 compiler. In addition, an error data instance must be initialized based on the error handler servlet request attribute defined by the servlet specification and made available through a page context to the page. This has the effect of providing easy access to the error information via the expression language. For example, an error page can access the status code using $page context.error-data.status code. By default, a JSP errors page sets the status code of the response to the value of the $page context.error-data.status code, which is equal to the 500 by default, but may set it to a different value, including 200 as it sees fit. A JSP container must detect if a JSP error page is set, referencing and throw a translation error. Now we are considering JSP commands. In commands in JSP pages in standard syntax in commands. A JSP command is of the form here. Body of the content is ignored completely. Comments are useful for documentation but are also used to comment out of some portion of the JSP page. Note that the JSP comments do not nest. The alternative way to place a comment in JSP is to use the comment mechanism of the scripting language. For example, here the comments in JSP documents. Comments in JSP documents use the XML syntax as follows here. The body of the content is ignored completely. The comment in a JSP document may be used for documentation purposes and for commenting out portions of a JSP file. Comments in documents do not nest. Now we are considering overall semantics of a JSP page. Its value varies. A JSP page implementation class define underscore JSP service method mapping from the request to the response object. Some details of this transformation are specific to the scripting language used. Most details are not language specific and are described here. The content of a JSP page is devoted largely to describing the data that is returned to the output stream of the response. The JSP container usually sends its data back to the client. The description is based on the JSP write object that is exposed through the implicit object out. Its value varies. Initially, out is an new JSP write object. This object may be different from the stream object returned from the response.getWrite method and may be considered to be interposed on a later in order to implement buffering. This is This is the initial out object. JSP page authors are prohibited from writing directly to either the print writer or output stream associated with the servlet response. The JSP container should not invoke response.getWrite until the time when the first portion of the content is to be sent to the client. This enabled a number of users of JSP, including using JSP as a language to glue actions to deliver binary content or reliably forwarding a servlet or change dynamically the content type of the response before generating content. Within the body of some actions, out may be temporarily reassigned to a different nested instance of JSP write object. Whether this is the case depends on the details of the action semantics. Typically, the content of these temporary streams is appended to the stream previously referred to by out, and out is subsequently reassigned to refer the previous nesting stream. Such nested streams are always buffered and require specific flushing to a nesting stream or their content will be discarded. If the initial out JSP write object is buffered, then depending upon the value of the auto flush attribute of the page directive, the content of that buffer will either be automatically flushed out to the servlet response output stream to obviate overflow, or an exception shall be thrown to a signal buffer overflow. If the initial out JSP writer is unbuffered, then content returned to it will be passed directly through the servlet response output stream. A JSP page can also describe what should happen when some specific events occur. In JSP 3.1, only events that can be described are the initialization and destruction of the page. These events are describing using well-known method names in declaration elements. Now we are considering including data in JSP pages. In directives. Here we are considering directive include directive translation time. This is syntax. This is file relative and specification. The object is static and content is passed by JSP container. Now we are considering syntax of expressions in JSP pages in expression language. The $sign open curly brace close curly brace and versus $sign open curly brace close curly brace. There are two constructs to represent EL expressions, $sign open curly brace expression and closing curly brace, and $sign open curly brace expression closing hash open curly brace and expression and close curly brace. While the EL passes and evaluate this one and this one the same way, additional restrictions are placed on the usage of these delimiters in JSP pages. EL expressions that is evaluated immediately is represented in JSP with the syntax of $sign. While the EL expression those evaluation is deferred is represented with the syntax of hash followed here. Now we are considering valid JSP page in overall structure in scripting. A JSP page is valid from a Java platform if and only if the page implementation class is defined by structure of the programming language class. After applying all include directives, together with any other classes defined by JSP contain is valid program for given Java platform, and if it passes the validation method for all tag libraries associated with the JSP page. Now we are considering a JSP page model in JSP container. A JSP page is represented at its execution time by a JSP page implementation object and is executed by a JSP container. A JSP page implementation object is a servlet. The JSP container delivers requests from a client to a JSP page implementation object and responses from the JSP page implementation object to the client. The JSP page describes how to create response object from a request object for a given protocol, possibly creating or using some other objects in the process. JSP page may also indicate how some events are to be handled. In JSP 3.1 only init and destroy events are allowed events. JSP container must render a JSP page for HTTP methods get and post with identical responses. The response for a head request to the JSP page must be identical to the response for a get request minus the response body. The behavior of the JSP container is undefined for other methods. The JSP page implementation class. JSP page, the JSP container creates a JSP page implementation class for each JSP page. The name of the JSP page implementation class is implementation dependent. The JSP page implementation object belongs to the implementation dependent name package, and the page used may vary between one JSP to another, and minimal assumptions should be made. As of JSP 2.0, it is illegal to refer to any classes from the unnamed, also known as default package. This will result in translation error. This restriction also applied for all other cases where classes are referenced, such as when specifying a class name for a TLD tag in a TLD. The JSP container may create implementation class for a JSP page, or superclass may be provided by the JSP page author through the use of the extend attribute of the page directive. Extend mechanism is available for sophisticated users. It should be used with extreme care, as it restricts decisions of a JSP container can make. It may restrict efforts to improve performance. For example, a JSP page implementation class will implement Jakarta servlet, and requests are derived to this class as per rules for servlet 6.0 specification. JSP page implementation class may depend on support classes. If the page a page implementation class may depend on the support classes. If the JSP page implementation class is packaged into a WAR, any dependent classes will have to be included, so it will be portable across all JSP containers. A JSP page author writes a JSP page expecting that the client and the server will communicate using a certain protocol. The JSP container must guarantee that request to and response from a page that use that protocol. Most JSP pages use HTTP, and the implementation classes must implement a HTTP JSP page interface which extend the JSP page. If the protocol is not HTTP, then the class will implement an interface that extend JSP page. Now we are considering a detection algorithm for JSP pages in page encoding detection. The following is a complete though unoptimized algorithm for determining the character encoding for JSP file. JSP containers may use an optimized version of this algorithm, but it must detect the same encoding as the algorithm in all cases. One, decide whether the source file is a JSP page in standard syntax or a JSP document in XML syntax. If there's is XML element in a JSP property group that names this file, then it has the value true. The file is a JSP document, and if it has the value false, the file is not a JSP document. Otherwise, if the file name has the extension JSPX, the file is a JSP document. Otherwise, try to find JSP root element in the file. Determine the initial encoding from the first 4 byte of the file as described as described in the XML 1.3 specification. The 4 byte sequence 3C, 3F, 786D use ISO 88591. For the byte sequence 4C, 4F, A794 use IBM 037. For all other cases, use UTF or UCS encoding given in appendix. Read the file using initial encoding and search for JSP:root element. If the element is found and is the top element, the file is a JSP document in XML syntax. Otherwise, file is a JSP page in standard syntax. To read the file, 3. If the file is a JSP page in a standard syntax, if the file is not preceded by BOM, check whether there is a JSP configuration element page-encoding whose URL pattern matches this file. Read the file using initial encoding and search for page encoding attributes in the page declaration. The specification requires the attribute to be found only if it is not preceded by non-ASCII characters, so simplified implementations are allowed. Report an error if there are a page encoding configuration element whose URL pattern matches this file and a page encoding attribute and the two name different encodings. D. If there is a page encoding configuration element whose URL pattern matches this file, page character encoding is the one named in this element. Otherwise, if there is a page encoding attribute, the page character encoding is the one named in this attribute. Otherwise, read the file using the initial encoding and search for the charset value within the content type attribute in the page declaration. If it exists, page character encoding is the one named in this character charset value. The specification requires attribute to be found only if it is not preceded by non-ASCII characters, so simplified implementations are allowed. Otherwise, the page character encoding is ISO 88591. If the file is preceded by BOM, read the file using the encoding indicated by BOM and search for the page encoding attributes in the page declaration. Report an error if any of the following conditions are met. If there is a page encoding configuration element whose URL pattern matches this page and whose encoding does not match the encoding indicated by the BOM. There is a page encoding directive attribute whose encoding does not match the encoding indicated by the BOM. 4. If the file is a JSP document in XML syntax, use these steps. Determine the page character encoding as described in the XML 1.0 specification. Note whether the encoding was named in the encoding attribute of XML prologue or just derived from initial bytes. Check whether there is a JSP configuration element page encoding whose URL pattern matches this file. Read the file using detected encoding and search for page encoding attribute in a JSP:directive.page element. Report an error if any of the following conditions is met. An XML prologue names in encoding there is a page encoding configuration element whose URL pattern matches this element and which names a different encoding. The XML prologue names and encoding there is a page encoding attribute which names a different encoding. There are a page encoding configuration element whose URL pattern matches this file and page encoding attribute and two name different encoding. 5. Read the file and read using the page character encoding. Internationalization issues. XML view character encoding. The XML view character encoding is always UTF-8. XML view character encoding is the character encoding used for externalizing the XML view of a JSP page or tag file. The XML view character encoding is always UTF-8. Now we are considering XML view of a tag file in tag files. Similar to JSP pages, the tag file have an equivalent XML document. The XML view of a tag file that is exposed to the translation phase for validation. During the translation phase for a tag file, the XML view is created and passed to all tag library validators declared in all tag libraries declared in the tag file. The XML view of a tag file is identical to the XML view of a JSP. except that there's an additional XML element defined to handle tag file specific features. XML view of a tag file is obtained in the same way that the XML view of a JSP page is obtained. Now we are considering a JSP page and its corresponding XML view in XML views. Here is an example mapping between JSP and XML. For this, the JSP page, and this is the XML view of the this page. Example, we can consider JSP exception, class JSP exception, a generic exception known to the JSP engine. Uncaught JSP exceptions will result in invocation of the error page machinery. This is in module jakarta.servlet.jsp and package jakarta.servlet.jsp. Here you can, as an error example, we can consider this one. The following directive requests no buffering and provide an error page. The page directive attribute error page defines a URL to a resource to which any Java programming language throwable objects thrown but not caught by the page implementation are forwarded for error processing. Any number of exceptions can arise when JSP page is executed. To specify that the web page container should forward the control to an error page if an exception occurred, include this directive here, and you can see the error page here. Here you can see this directive makes an object type javax. Here, for example, jakarta.servlet.jsp.error data available to the error page, so that you can retrieve, interpret, and possibly display information about the cause of the exception in the error page. To access the error data object in an EL expression language expression by the way of the page context, thus $, open brace, curly brace, page context dot error data dot status code, close curly brace, retrieves the status codes, and here the $, open brace, page context dot error data dot throwable date dot throwable retrieves the exception. Here the cause, you can retrieve the cause of the exception using this expression here. You can see cause here. You can also define an error pages for the var file var that contains the JSP page. If the error pages are defined for both var and the JSP page, the JSP page error page take precedence. As an example 7, we can consider JSP model 1 architecture here, and here here you can see monolithic or compound JSP here. When JSP were first introduced, some developers recognized their potential to replace the awkwardness of embedding HTML output in a servlet with the convenience of scripting. Many decided that since JSP were passed into servlets internally, they were just a new syntax for servlets. So they built servlets including access to models, control logic, and output. This example shows the worst case of JSP design here. Actually, here the this example has some problems. It performs operations belonging to the model, view, and the controller. The example this example combines the functionality of JSP and servlets, but represent the worst of both worlds from the point of view of maintenance. The HTML is confusing, often duplicated. And spread throughout the file in an opaque way. The Java code is embedded awkwardly, again hard to find and follow. There are actually two common anti-patterns. The monolithic JSP anti-pattern occurs when JSP pages do more than their fair share of the work. Often acting as both view and controller. While this example doesn't interact directly with the model via JNDI or JDBC, it would be a logical extension, further destroying the separation of model and controller. A closely related anti-pattern is the compound JSP anti-pattern, in which multiple JSP files are crammed into one using Java conditionals. In the example here, our code exists the return value of a call to do logging, and displays different pages based on the result. Now we are focusing on Java Beans model. In computing based on Java platform, Java Beans is a technology developed by Sun Microsystems and released in 1996 as part of JDK 1.1. Now we are considering Java Bean scope in a JSP. Java beans have scope just like all variables. You declare this in a JSP colon use bean element. When you use the bean for the first time, there are multiple scopes possible for bean. They are page, request, session, and application. We have started the page, which is at least variable went till the application, which most visible. To make easy to understand, took at the picture here. It shows the how to scopes are arranged. Bean objects are only accessible or available or accessible in a scope that were declared and created to be visible. Let us look at these scopes in a little more detail. Page scope. If a bean is declared with the page scope, it is equivalent to local variables in regular Java code. If a bean is declared with the page scope, the reference to the bean disappeared once JSP page is processed. It cannot be referenced by any other JSP or servlet if a forward or include is used. The request scope, if a bean is declared with the request scope, it can be accessed by any JSP or servlet within the same request. The reference remains alive in other servlet or JSP that is called by the JSP and colon include and JSP colon forward or using request dispatcher object. Session scope. If the bean is declared with the session scope, it is available to all JSP and servlet that are accessed by the single user. Even if the user navigate across multiple pages, the beans are available for use. You can declare a bean with session scope. Application scope. Application scope is the widest and most visible scope. The bean declared with the application scope is visible to just about servlet or JSP in the whole application context across user sessions. Though this might sound awesome, we usually do not declare beans with this scope because it can end up affecting us instead of being beneficial. For example, if the value entered by one user in his web page is visible to another guy, it would be disastrous, wouldn't it? So if we need to be cautious before using this scope. So here you can see application most visible scope inside it session, and then inside request and inside it page list visible. As an example, we can consider this code segment. Here you can see the action JSP colon use bean. A JSP colon use bean action associates an instance of a Java programming language object defined within a given scope and available with the given ID with the newly declared scripting variable of the same ID. Here you can see the attribute ID, the name used to identify the object instance in the specified scope namespace, and also the scripting variable name declared and initialized with that object reference. The name specified in this case sensitive. The name specified is case sensitive and shall conform to the current scripting language variable naming conventions. And here you can see class attribute, the fully qualified name of the class that defines the implementation of the object. The class name is case sensitive. If the class and bean name attributes are not specified, object must be present in the given scope. Here you can see this is introduce a new block here, and here the tag above creates or obtain a customer bean reference, associate it with the name customer in the page context, and declared a Java programming language variable of the same name initialized to the object reference in this block scope. Here you can see the usage of it, and here close the block. The variable customer is out of scope now, but the object is still valid and accessible via page context. As an example too, we can consider this one. The action JSP colon set property. The JSP colon set property action sets the values of properties in a bean. The name attributes that denotes the bean must be defined before this action appears. Here you can see attribute name. The name of a bean instance defined by JSP colon use bean action or some other action. The bean instance must contain the property to be set. The defining action must appear before JSP colon set property action in the same file. The property attributes, the name of the property whose value will be set. If property name is set to asterisk, then the tag will iterate over the current servlet request parameters, matching parameter names and values types to property names and setter methods types, setting each match property to the value of the matching parameter. If a parameter has a value of null, that means empty string, double quotation, the corresponding property is not modified. Here you can see the value attributes, the value to assign to the given property. This attribute can accept a request time attribute expression as a value. The action may not have both param and value attributes. As an example 3, we can consider action JSP colon get property. The JSP colon get property action places the value of a bean instance property converted to a string into an implicit out object from which the value can be displayed as output. The bean instance must be defined as indicated in the name attributes before this point in the page, usually via a JSP colon use bean action. Here you can see a name attribute, the name of the object instance from which the property is obtained. Here you can see property attribute names, the property to get. Here as an example 4, you can see here the expression language. Here $, open curly brace, java bean dot variable, closing curly brace. The value of the variable in the object java bean is this one. Here the expression language, and expression language makes it possible to easily access application data stored in Java Beans components. As an example 5, we can consider this one. This is in expression language, this code segment. There are two constructs to represent EL expressions, that is the $sign expression and hash then expression here. While EL passes and evaluate $sign and hash in the same way, additional restrictions are placed on the usage of these delimiters in JSP pages. EL expression that is evaluated immediately is represented in JSP with syntax $sign open curly brace closing curly brace, while EL expression whose evaluation is deferred is represented with the syntax hash open curly brace, then expression, and then closing curly brace here. So as an example 6, we can consider this code segment. So in the controller class, we have already created an object of an employee bean here, and pass some values by using setter methods of the bean class. This object is then stored into set attribute method of the HTTP servlet request object. We forward this request object to the beandata.jsp by using request dispatcher to make the attributes available there. Here this method is called by the servlet container to process GET request. Is storing bean in session here. As an error example, we can consider this one. Here they cannot find any information on property data in a bean of type com.example.csa_server.db funcs.